Hello everyone and welcome to this amazing session where we will be building an end-to-end DevOps project for beginners. And yes, we are going from hello world to production. Yes, and we are going to build this. Okay, now who is this video for? For if you are new to DevOps, if you are exploring different tools, but you don't know the connection of these tools, or you don't know the big picture, okay? You have idea about Docker, maybe Kubernetes, this and that, but how to connect all of this, how all of this makes sense, connecting all of the dots and creating a perfect DevOps workflow. This is why I have given the title or theme of this session is connecting the dots. I will be showing you the bigger picture so you have a perfect idea. And what's the goal? The goal is I will be sharing with you the most minimal codes, okay? No complexity, nothing. We won't even go for the best practices, okay? So the goal is clear. It is to create our foundation, okay? A foundation on which you will be able to build your building later on. Clear? Okay. That's why I have also entitled this session as level 0, meaning in future we will be going for level 1, level 2 and on, integrating best practices, securities, etc. So stay tuned for those sessions as well. So this was the intro. Let's get for our agenda. What we are actually going to do. Let's write the agenda. As I've mentioned, we are going to write hello world and we are going to use the simplest language in the world, that is Python. Now, writing is just not enough. We want to see it in a browser, right? In Chrome or Microsoft Edge, whatever. For that, we are going to use Flask. It's a library for making websites in Python. Okay? We will keep all of our codes in GitHub. In GitHub for version control. Now, what is version control? Version control means we know our code might have updates time to time, and we will have version 1, version 2, version 3, etc. Version control enables us to go back and forth between versions and see the difference in our code, to track, have a history. Not only that, GitHub also has lots of other features as well. Okay, so this was the version control and we will be using GitHub. Then comes that we will be using something called containerization. But why? We will build our app in a machine, right? In a computer, and it might have, let's say, Windows system, Windows. You might also have another system which is Linux. Now, if you build your app Hello World and put it in Linux system, then it might not run. Why? Because it is too much dependent on Windows. Okay, it might not run. This is why what we are going to do is that we are going to make a container, a box out of it. And what we are going to do, we are going to give it all the codes, all the dependencies that is required to run everything in a box, and we will call it an image. And what will that ensure? What will that do is that after we create the image, we can run the image anywhere in any system, since it has all the codes and all the dependencies in it. We can run it in Windows, we can run it in Linux. And how we are going to do that? We're going to do that using a tool called Docker. Okay, next we are going to use a CI tool, that is, I think you know, continuous integration. It's mainly used for automation. Now, what does automation mean? Automation in vague terms means if an event A occurs, it will trigger a chain of events B, C, D. In our case, we will have all of our codes in GitHub, right? So if someone integrates anything, that is any push happens in our code, it will trigger a sequence of commands. In our case, what we will do is that it will create a Docker image that we previously created manually. Now it will be automated, and the new image would be pushed to a registry called DockerHub. It's a personal registry to keep all your personal images that you create using Docker. Clear? Since it is a repetitive task, we will use CI and we will be using GitHub Actions. GitHub Actions for this automation. Clear? Okay. Up until now, up until this, we have our part 1. Then comes part 2, and it is about cloud. We know cloud is very important in DevOps, okay, and we will be using a cloud platform too. We will be using AWS, and since we have used containerization method like Docker, we will also include a production grade container orchestration or managing tool, and the most famous one is Kubernetes. Kubernetes. Now AWS has its own Kubernetes system, a service. It's called EKS, and we are going to use that. Okay, fine, but we need to build it, right? We can build it by going to the AWS console, using the UI, clicking on stuffs. But is it efficient? No. In production, we don't do that. Rather, we use IAC tool, that is infrastructure as code, meaning you just write code and it will create those services. For that, we are going to use something called Terraform. We are just going to write code in Terraform, and we will see in our AWS account that EKS has been created. Clear? This is our second part. As you can see here, this one. We would use Terraform to build Kubernetes in AWS. Then, after we have built EKS, let's say this is the box. Yeah. After we have built our AWS EKS, we are going to run our code, the app, the hello world in EKS, and this is the production environment. This is the prod environment. Okay, but is running enough? Not necessarily. There are lots of other stuffs. We need to ensure that the app is properly running, all the requests are handling properly, the resources are handling properly, nothing is out of the rules. Okay, we have to monitor, we have to observe, like GPU usage, the latency, the request per second, etc. For that, we are going to use a tool called Prometheus. It will help us to track metrics, as I have mentioned, like GPU usage, latency, etc. Now, we just don't want to track records, right? We want to see it in a dashboard, make it visualize. Okay, and for that, we are going to use another tool, a dashboard tool called Grafana. Clear? Okay, this is our third part, that is observability, which will enable us to observe our production system. Then the last part, that is CD, continuous delivery. Now what does continuous delivery mean? Is that we have our code in our GitHub, right? Yes. Now what we want is that any change to this, any change in our GitHub code will also change the actual production environment in EKS. For instance, let's say we have 3 containers running in our code. We have written the code so that 3 containers should run. So EKS is in 3 containers running. Okay, we call it pod, but for simplicity, let's call it containers. Now in the code, if we just change the variable from 3 to 5, what CD tools do, it also change the production environment to 3 to 5 without any manual code, without explicitly manually typing that EKS shift from 3 to 5. No, we don't need to do it here. We just change in our GitHub code, and that's enough. For that, we are going to use a tool called ArgoCD, and this is the continuous delivery, and it will be our part 4. So yeah, guys, we have a proper workflow running. We have hello world in Python Flask for website. We are going to do version control in GitHub. We are going to containerize our app using Docker. We are going to have a bit of automation using CI tool GitHub Actions. Then we are going to for our production environment creation using Terraform, and we will be creating an EKS, okay, Elastic Kubernetes Service in AWS. After we have our production environment created, we need observability. For that, we have Prometheus and Grafana for dashboarding. Finally, for continuous delivery from code to production updates, we are going to use ArgoCD. Yes, it's going to be very, very exciting. I know you're excited, me too. So stay tuned and let's go forward. But before we get to the actual hands-on and coding, we need a machine to work on, right? We need an environment. For that, we have a few options. Number one is to use our local machine, okay? Local desktop, laptop, whatever you have. And the second option is to use cloud. For that, we also have two options. First one is using a cloud provider like AWS, and we can use their virtual machine like EC2. Now, by virtual machine, I mean a computer with a resource running in cloud. Okay, so we will have Windows or Linux or whatever system we want, and it will be running on AWS cloud. This is virtual machine. And the second option is something called GitHub Code Space. This is also a virtual machine that is running on cloud, and it is provided by GitHub. Okay, after we have set up our machines, then we need to set these tools too. Okay, we will be needing these tools throughout the entire project, and once we are done with the installation, we are good to go with our project. Okay, what are we going to use? Well, we are going to use GitHub Codespace. Why? First of all, in our local machines, each of us has their own versions. Each of us has different specs uh, and different libraries already installed. So there might be installation or dependency clashes. So I don't want to go with the local one, and that's why I have chosen to go with GitHub Codespaces. And the second reason is that it is free. This one is free. I think it is 27 hours per month for each account in GitHub, and everyone has a GitHub account. So we will be in the same page. Okay, we will be starting at the same 0 point. That's why I have chosen GitHub Codespaces. And if you want to use AWS, you can do that, but yeah, I think it is the better option. And another point for choosing GitHub Codespace is that in GitHub Codespace we have almost every tool pre-installed except for these two, the last two, AWS CLI and Terraform. Okay, so most of our setup work is already done. We don't need to bother about those. Okay, but if you are using AWS instance, then you need to set all of those tools. Okay, I'm showing you that, but let's get to our GitHub Codespace, shall we? Okay, so I have it here. Yeah, this is my GitHub. Now click on new to create a new repository. Let's name our repo demo. Demo project. I think that would be better. Demo project. Okay, and you don't have to do anything else. Create repository. Wait a little bit and it should be created. Yeah, there you go. We have created our repo, and let's create a new file. Click here, creating new file. Let it load. Let's name our file app.py since it is our application. Let's not write anything yet. Okay, and let's commit the change. It has auto commit messaged us, and so yeah, anything wrong, page not found. Yeah, I think it was a network issue or something, but yeah, we have created our file. So after we have created the file and the repo, we can create the code space. Let's go to code space from the side panel and click on new code space. Okay, we have to select a repository, and let's select what we have created just now, demo project. Okay, we have selected it. Nothing needs to be changed. Okay, and click on create code space. It will take a bit of time, and after that you'll be able to see what we have. Basically it will give us a VS Code like environment, as you can see. And if you use AWS EC2, then you won't have this type of IDE type of environment. Okay, it will give you a terminal, so you will have to work on the terminal. But in our case we have a cool looking VS Code, so it will take a bit of time. So let's wait for a bit. Yeah, it is loading. And let me show you what I meant by already existing tools. I have said without the last two, these two, we already have the rest of the tools pre-installed. So I have a command to run to check all the versions. Here you go. Our environment is all set up. So let me show you. Let's allow this and press enter. Here you go. And as you can see, there's some response, and let it finish. As you can see, we have pip version. Sorry, yeah. We already have Docker. We already have Git installed. We don't have Terraform and AWS installed. Command not found. But after that we have this. This is for kubectl. These 3 lines, and this one is for Helm. We also can see Python is also installed, and pip is there also. Okay, I've just pressed the entire command at once. Okay, you can do it separately. Okay, let me show you. For instance, I can write Helm, and I think the command, yeah, version, Helm version. Okay, I think it's just version, if I'm not wrong. Let's see. Yeah, so we have Helm already installed. Clear? But we don't have these two, so let's install them. And regardless of the tool, it is very easy to install any of these. Okay, let me show you. Just go to your browser and type anything. Let's say since I am going to install Terraform first, let's say Terraform install. Okay, you can ask Terraform download or whatever. Okay, you can even ask AI to do your work, give the code for you. So we are here, and since we are using Ubuntu, if you noticed, it is using Ubuntu, as you can see. uh, that's why we have to use the commands for Ubuntu. If you are using Windows, then a file will be downloaded and there's some other steps. But for Ubuntu, it is just copy this command, go to your terminal again, then paste, press enter, and you'll see after a few moments Terraform is created, installed in your machine. Okay, similarly, let me show you first this one, Terraform version, version, and you can see we have Terraform installed. Previously it was not. Then what we need to do is install AWS CLI. Similarly, just write AWS CLI install, download, install, whatever. Okay, just give an instruction. It is very easy to find. Okay, go to the official documentation. Again, we are using Ubuntu. Okay, so scroll down. It is Linux, and go down here, and here you can see to install the AWS CLI, run the following command. So let's copy this. Again, let's go to the terminal and paste it. We have pasted it, and let's see, it is taking a bit. Okay, yeah, here you go. We have AWS CLI. Let's check it. We are going to run AWS version and press enter, and here you go. Our AWS CLI is all set to run. Okay, similarly you can install any other tools that I have mentioned. Like if you want to install Docker, just write docker install and search. You will see the proper documentation. You just go to the preferred system you're in. I'm in Ubuntu. I'm selecting Ubuntu. If you're in Windows, whatever, any distributions of Linux, you can go there. Okay, so yeah, here you go, and all the steps are mentioned. Okay, just follow those. To install the latest version, just run this command. Clear? Okay, I think it's pretty easy and you can do it. So yeah, guys, we have created our virtual machine. we have created the machine in GitHub code space. We have created the GitHub repo, and then install all of these tools. Okay. Another advantage that we get by using code space, I've mentioned that we are in the same virtual machine, in the same starting at same page, starting from the zero, everyone at the same pace. Second thing is that we have pre-installed tools, and the third one is that we are already using GitHub, so we are already using version control. Okay, we have selected the repo. Remember, when creating the code space, we selected a repo, and if you go to the code space again, you will see that app.py is already present there. See that? App.py is already present there, meaning we are already in our GitHub repository. Okay, if you go to the repo again, yeah, here you will see commit. Okay, each time we make commits, it will be here, and we can traverse. Okay, we'll have version control from here. Each time we commit, we'll see the list goes on and on and on, and we can go back and forth in each of the commits, see the differences. Okay, so by using code spaces, we are already using version control. Okay, so we have set up the environment, set up the machine, set up the all necessary tools, and we are good to go for our first step. So for the first part, how to write hello world from text to a website. So this is hello world in handwriting. How to convert it in a Python code? It's simple. Add two quotation mark back and forth, wrap it in a first bracket, and in front of it write print. That's it. Print is a Python function for printing anything, and inside these two first brackets you write whatever you want to print, and make sure it is in between those quotation marks as well. Okay, so let's go to our already created environment. Okay, here I have a file called app.py. Let's write hello world, what I have mentioned. Let's zoom in a little bit. I think that's better. Okay, let me skip the terminal for a bit. Yeah, hello world, hello world. Okay, this is the text hello world. What I'm saying is that give a quotation back and forth and a first bracket, then in front write print. Clear? Okay, after that what we want to do is just run the file. Clear? So let's open the terminal and let's write python app.py. Python meaning it's a Python file, and Python will execute this file since it has .py at the end, and the name of the file that I want to execute is app.py. So let's press enter, and here you go. As you can see, hello world has been printed. So from text to Python code, done. Now I want to see it in website. How? So in order to convert a Python code into an website, we have multiple options to convert it into website. How do we do that? We do that through different Python libraries. And one of the most easiest Python libraries to convert Python code to a website is called Flask. Flask. So we are going to be using Flask. But in order to use Flask, first we need to install Flask. So let's do that. It's very simple. Just write pip install Flask and press enter, and it should download. It will take a bit of time. Okay, and we are done. As you can see, Flask 3.1.2 has been successfully installed. Clear? Okay, now about the code. How to convert this hello world into a website using Flask. As I have mentioned, my goal is to have minimal complexity code. Okay, no complexity whatsoever, the most minimal code possible. So the most minimal structure of a Flask application is this. As you can see, there are 4 parts: 1, 2, 3 and 4. Now what are these? Let me go line by line. First, from Flask import Flask. What does it mean? I have already installed Flask library, and in that library there is a tool called Flask. It is like a toolbox. You can assume Flask is a toolbox, and inside there are lots of tools. Among them, this is a tool called Flask with a capital F. Okay, so we are just telling that, yeah, I am going to import this tool. Clear? Okay, fine. The second line is basically saying that this is my app. What this Flask basically does is that it creates the Flask app. Okay, creates the overall application. Okay, and we are saying store it in this variable called app. Clear? Okay, fine. What is this? What is this? This is, you can say, a variable. Let's assume it's a variable. What it does is that if I have a file called app.py, and if I execute it like I just did here using, where is the command? This. I executed that, the app.py file, right? Whenever I execute something like that, behind the scene, what happens is that something called this. There's double underscore. I think it's called dunder if I'm not wrong. So dunder name dunder, you can assume it as a variable. It looks for a value. If the current file you are using is run, if it is the right file, then you will receive the answer as main. Okay, if you run the file where you at, if it is the proper file, then you will have this output behind the scene. Okay, and this command is basically saying that run this file, whatever there is in the file. Okay, and how are we checking it? Whenever we are doing Python app.py, first of all, the very first thing is happening is this line, the very last line, that is if name equals to main. As I've mentioned, if my file is the actual file that is going to be ran, then the output should be this. So if the output is properly this, then the next line would get executed. And what is the next line? It is basically saying whatever app you have created in this line, whatever you have created in this line, just run it. Just run it. And there are some parameters here. We don't need to bother about host, but we need to bother about port. I think there's also a default port value, but we can assign it also. That means that the host for this app would be 0.00, that means local, and the port would be 5000. Whenever I input this in my local browser, it should run my Flask app. Clear? So this was importing the library, this was creating the app, and this was actually the execution part. Now what is this? This is the body of the app. Okay, so this is a structure or syntax, you may say it. These three lines we write exactly as it is, app.route with a decorator in front, and then we have something called endpoint. Okay, here we have slash in between the brackets and uh, quotation marks. Okay, now what does this endpoint or slash mean? So let me go back to my GitHub code space, and let me go to a repo that I have created for you guys, demo project. Okay, let's go there, and on top of the search bar, as you can see, there's a address. Okay, what does it mean? It means, this part is meaning use HTTPS protocol, then go to this address, that is github.com. In that you will find a ID, that is this, and inside that ID you have a demo project. Okay, so the location in my ID of this project is this part, slash demo project. Okay, if I just go to slash, just slash, okay, let's see what happens. It will redirect me to my home page. So basically this slash is an endpoint. Whatever we write after the slash or including slash is an endpoint. It's basically an address. So demo project was an address, this was an address, okay, going into the demo project, and if I skipped it, it got to me the home location. Clear? So similarly, this part, the inside of these first brackets, means an endpoint. Clear? So what I'm telling is that whenever this is ran, the execution lines, okay, it will trigger this app, and the app has this body, and in this body whenever I type in slash, it should run this function, okay, this function, and inside that function I have something in return, and whatever I return would be shown in my website. So what do we want to show? We want to show hello world. So let's pick hello world, let's pick it up and place it here. Where is it? Yeah, here you go. Let's place it here. Let's downsize a bit. Yeah, fine. So now we are fine. Our hello world is now turned into a Flask app or website. I hope we are clear about each and every line. Okay, so let's get to actual hands-on. Let me copy it. Okay, so it will be time saving. I've copied the code. Let's go to our code space and let me remove this for a bit, and let's paste it. I've pasted it. Okay, so what changes do I need to have? I have to have this hello world where inside the return. Okay, so let me paste it here. Clear? Okay, so I have extra quotation marks, I don't need those here also, and let me reduce the spaces. Yeah, fine, I don't need this one. Let me get rid of that, and here you go. Okay, now I just included this hello world inside this template. Which template? This template. This entire thing you can say it as a template. This is the most minimal thing, the most minimal structure of Flask. Okay, there are complexities, but since we are aiming for most minimal, this is the most minimal. Okay, you just put your hello world inside this. Okay, so we have done it in this line, as you can see it. Now just save it. If you don't save it, it won't run. Don't forget your control S. We have control S. Now again go to the terminal, let it load, write python app.py and press enter, and you will see it is running on, okay, let me open it. It is running on this host 0.0.0, which is basically the local host, and the port is 5000. Okay, the port is 5000. Now you might assume that whether if it was in my local VS Code, since I'm using a cloud VS Code in GitHub code space, regardless of anything, if you use your local machine, if you have Flask installed, you will see that the code is perfectly running. So let's see whether our code is running, and here you go. We are seeing hello world inside our browser. Okay, so that's that, guys. And if you want, you can add another function. Let me quickly add another function, an endpoint. So let's do it. So let's name it new. Okay, if you have a new function also, if you have new endpoints also, you need to have unique function. If you have a common function or the same function somewhere else, then it won't run. Okay, so let's have new world with all capitalized. Okay, save it, control S, then you need to again initiate that. So control C to stop the previous one, and again run this. Fine, so again we have the link, and here you go. So for the slash we have hello world. If you just add slash, it will return the same thing, but if you add slash new, the new endpoint we just added, it will show you the new return, that is new world. So yeah, guys, it was our first part, that is from hello world to our website Flask app. Clear? Okay, so basically what we have done is that we have created hello world uh, with Flask and Python. So we are done with this part. We are also done with this part since we are using GitHub. But are we actually done? No. Why no? Because we are already using code space. That's fine. But we have updated the code itself. At the beginning, the app.py file was empty, remember? Now we have added stuffs. Okay, that's why now we again have to update the GitHub, update the Git with a version 2. Previously we had version 0, now we have version 1 since we have made changes. That's why we have to push the code. So yeah, let's stop that, and we have to push it. First we need to add, so let's add whatever we have in our repo. Let's zoom out for now. we don't need it. Yeah, we have only one file here, app.py. If you remember, I had AWS CLI zip files. When you refresh it, it automatically goes away, and if you still delete it manually, it's fine. Once it is installed, you can delete it, your AWS CLI will run perfectly. So I have one file here, and it is changed. Okay, previously it was empty. So git add dot means basically add whatever changes in whatever how many files there are into the staging area. It is called in GitHub, if you are familiar with it. So let's press enter. All of my changes are in the staging area. Then what we need to do is commit it, right? Get commit m for the message, and let's say what we have done. We have app.py is now uh, in Flask app, is now a Flask app. Clear? Let's press enter, and here you go. There's a change, and it is being detected by Git. Now, how to push it in the actual GitHub? If you again go back to my repository, that is demo project, you'll see that we still have app.py, and we still have an empty file. Okay, yeah, it's empty. Basically it's empty, that's why it's not showing anything, and we have only one commit. Okay, now we have made change and we have added and committed. We need to push it so we can actually see it in our GitHub account. So let's git push and press enter, and we are done. Now again, let's go to our demo and refresh it, and here you go. We can see our code perfectly, and if you go to the history, now you should see two commits. Yeah, first one is create app.py, and the second one we just built a bit earlier. Okay, and this is version control. If I want to look at the previous version, I can click on it and review the code, and we can see the changes. It is basically showing us that there's been changes added. Previously it was null, and now we have something. Okay, previously it was like this, there was nothing. Okay, clear? Okay, this is version control, what we are talking about. And here you'll see all of the comments. So guys, we are done with this step, and we are using this step. We will continue to make progress, and after each step we are going to commit, and you will see all the history in our version control tool, that is GitHub. Clear? Okay, now how to do containerization using Docker. But first, why do we do containerization? Suppose we have an app here, and we have two systems. One is Windows and one is Linux. Now suppose my app was built on this machine, Windows machine, and it ran fine. Okay, now I put the code in the Linux machine. Will it run? Well, it might not. Okay, why? Because when we have created the app in Windows, the application might get too attached to the system of Windows, but Linux doesn't have the same functionality or same structure as a Windows operating system. That's why our application might not run. For analogy, we have Python in Windows, but in Linux or Mac OS we have to use Python 3. Similarly, we have pip for Windows, but in Linux or Mac OS it is pip 3. So like this, there are difference in the operating system, how they handle their stuffs. Okay, so your application might get attached to a specific operating system, and this is the famous problem that runs on my machine. Runs on my machine, meaning if the application is built on my machine, and then it only runs on my machine, not every machine. Okay, Docker solves this problem, or containerization tools solves this problem. How? We have the code application here, code of the application, and we add the dependency also here, and then we create a box out of it. This is the box. Okay, this box is created by containerization tool like Docker. When you have the box created, what we can do, rather than typing or creating the application inside a machine, we just shift the box here and run it, and the application runs. Again we shift the box into another system, and the application again runs. Now why? because now we are not dependent on a specific system. Rather, we are having a box where we have all the dependencies and the code included. I mean everything that is needed to run the application itself. So since it is inside a box, we can shift it from one place to another, and regardless of our local system or local machine, the application runs. Okay, so this is the problem that containerization solves. Now, how to do this containerization using Docker? In our VS Code, we generally need three files. We have our codes of the application, then we need something called requirements.txt, and we need something called Docker file. Okay, we can have something called Docker ignore as well. It is similar to .git ignore. Docker ignore means that if I don't want a file to get included in our Docker build up, okay, image creation, then we can write it there. Okay, so code is clear, our application code. Requirements.txt is basically say we are using Flask in our code. So Flask is a dependency. So we are going to include Flask in this requirements.txt. So whenever Docker runs, it will install this Flask so that the code gets run. Why Docker file? Docker file is like the instruction manual, the steps. Steps 1, 2, 3 to build your box. And that box is called an image. Okay, it's like the instruction. Okay, step by step by step. Okay, so this Docker file is the main deal, and it can be simple and complex. We can do whatever we like with it. But since our goal is to have a most minimal code, so I have a minimalistic code here so that we get an idea of the concept that Docker uses. Okay, sorry. Yeah, fine. So I have a very basic, very simple Docker file codes here. Okay, and it is only 6-7 lines. So let's get to it. What does this line mean? From Python 3.12 Slim. Well, it is actually a Docker image pre-created in DockerHub. What is DockerHub? DockerHub is a registry where all people around the world create images, create those boxes, and put it in that. It's a library. Okay, you have books in library. Similarly, you have Docker images in DockerHub, and if it is public, people can import those in their machines and they can run it. Okay, so in order to run our application in a container, we need a base image, okay, to work on, since we are not using the local machine. Okay, but we do need a system to work on, right? That's why what this line does is that it creates a base image, a base image. Okay, and if you go to the Docker Hub and type in this, you will find it. Okay, I have already went to Docker Hub and searched it for you. Here you go. I'm in Python. Just search this. Here you go, python.3.12 slim, and search it, and you should see this 3.12 slim. Click on it, and here you go. Every code that is in that file is present in this Docker GitHub repo. Clear? So it is already available. You can say image that we are going to use as our base. Now for the second line, what there slash app. What this will do is that it will create a box on top of our base image. It is basically a working directory. Okay, a place to work on. Like we have folders, so it's basically a folder created in the base image on top of base image. Okay, simple. Then we have something called copy requirements, and see this dot. This dot is basically means this folder. Okay, if we had written slash app here instead of this dot, it would mean the same thing. So what copy does, this is the source and this is the destination. So we are having requirements.txt in our slash app. So we are having requirements.txt in our slash app folder. So let's say after running this command, that line, we will have this. Suppose this is requirements.txt. Then in the second line, we have another copy, that is app.py into that same folder. So we will have our application code into that folder. So let's say this is our application code. Clear? Okay. Then in this line, run pip install requirements.txt. When this line is executed, the base image will run this command and install all the requirements needed to run your application. It's just exactly like your regular machine VS Code. You first have to install all the dependencies, the libraries, then run your code. Similarly, here instead we are not using the local machine, we are using a base image to do our task. So again, we are installing all the dependencies first. Then this command expose 5000. What this means is that we are sticking out a hand out of the box and the address is 5000. If anyone wants to talk to our box, talk to our application inside the box, he needs to connect with 5000 and he will enter the box. Simple as that. We are exposing a port. Finally, the last line, Python app.py. It's basically the executing command. Like as I have shown you previously, that we execute a Python file using this command. So our application is in app.py. So basically, it is getting executed. In the last line, so base image basically has all the code, all the dependency. So executing is remaining, so it executes. After that, our application is all ready and it is now a entire Docker image. Clear? Okay, fine. So let me copy this. Okay. So we have understood the process, the concept that Docker behind the scene uses according to the Docker file. And ultimately what we get is that this is our image created. We might have any name. Let's say we might have named it hello world, hello world. And we also have to give a tag. If we do not give a tag, it will be latest. Let's give a tag v0. Clear? So this is the image that we create. But how do we create? We have the code, the requirements, the Docker file and all. We create the image after we run docker build. This is the command that creates or builds our image. Clear? Okay. Then what? Then suppose you are in a machine, okay, that has Docker, and you have that image in your machine, or you have pulled that image from DockerHub, okay, but it is now in your machine, that image. Then you run this command, docker run. When you run this command, docker run, your image turns into a container and your application runs locally on your machine. What it does is that, suppose this is your machine and it has a port called, let's say, 8000, okay, and your docker image, that is hello world, is already existent, and as I have mentioned previously, it is exposing port 5000. Now when you run this docker run command, what it basically does is that it creates a bridge between a port of my local machine 8000 with the port of my docker image, that is 5000. It basically maps the ports. So whenever someone types localhost 8000, it goes to this and maps to this, and whenever someone maps to port 5000 in the image, it basically runs my application that is in the image. Clear? So this is the concept of creating a container or image using Docker. Now let's get to the hands-on. So let's go to our code space that we have previously created. We have our app.py. So what else do we need? We need Docker file. So let's create Docker file. Okay, it is created, and let's copy this command exactly as it is. So we have copied the code and we have our Docker file. Next we want our requirements.txt, and here we are going to be using Flask. That's why we just write the name Flask. Don't forget to Ctrl S to save it. For this one too, don't forget this. After that, we need to do our Docker build as I have explained with you here. These are the two steps. This is the first step, Docker build to create the image. Now we can have a note, just type Docker cheat sheet, and it is quite handy note to have all the common commands in Docker. Go here and you'll see this. Yeah, so it has all the necessary commands, and for image creation we have this command here, that is docker build -t and image name in dot. Okay, so we are going to do that in order to create our Docker image. Since we have already three required files, app.py, the code of application, the Docker file, and the requirements.txt. So let's write docker build -t. Let's name the app hello world, and dot. What does this dot mean? Dot is basically meaning the current working directory, and it is indicating this slash demo project. If I had any sub folder inside, then I have to mention that subfolder. Like if I have let's say under demo project new, then I have to mention dot slash new, but just the dot means it is in demo project location. Here, okay, so let's press enter and let's see the step-by-step process in building our Docker container, Docker image. So previously I had tried this, that's why it ran so fast. It was doing from cache, but if you run it for the first time, it might take a minute or two. And as you can see here, that it is run sequentially. This is the step one. As you can see, it cached since I ran it before the making the tutorial. That's why it is taking from cache. Step 3, step 4, step 5, and the image is created. Now we can search Docker images and look all the images currently present, and here you go, Docker image with the tag latest. As I have mentioned previously, if we don't put a tag, then it will have the tag latest. Okay, now for the second one, that is Docker run. What does Docker run do? Docker run basically uh, runs your Docker image and it creates a container. When you run your image, it becomes a container running in your local machine. So what's the command for it? Again, go to the cheat sheet, and for in container part you'll see this docker run -p host port and container port, and at the very last, that is image name. Okay, we can also add the container name if we like. Okay, using this parameter called name. Okay, sorry, yeah. So basically what we are going to do, I have explained here, we are going to be exposing our local port 8000 with the container port or image port 5000, and we are going to map them together. So let's do it. Let's go to terminal and write docker run -p for port mapping, that map 8000 with our container or image port, it is exposing at 5000. Then let's give the name of our container, what, hello world container. Yeah, then let's give the image name, which is hello world we just created. Make sure it is the right one, okay guys. And it's very important that the last one is the image name. Be very careful. The name right after this name parameter is the container name. Okay, be mindful about that. After that, press enter. Let's go. Okay, and we should see our application running, as you can see here, and a port has opened. Let's click on that, and here you can see it is opened in the container port 5000 and the local port is 8000. See, so our GitHub code spaces 8000 port is mapping to the applications or containers 5000 port. Okay, so let's go to the actual output, and here you can see hello world. Clear? Okay, fine. We have another endpoint called new. Let's see if that works or not, and new also works. Clear? So yeah guys, we have successfully created our Docker image and containerized our application. Now we have finished this step, so Control C to stop this. Control C. Okay, since we are using version control, we have to push it to our repo, right? Currently if you go to the repo, you'll see there's two commits we have made previously, and if you go to the code, the current situation is that we only have app.py, but we have updated. Okay, we have created the Docker file, have these two new files and successfully executed them. So we need to push them to our GitHub. So first let's add all of the files and changes to the staging area. After that, let's do git commit, and let's give a message that Docker image creation. Press enter, and you will see two files changed, as you can see here. Okay, after that we need to push. so that we can see the changes in our actual GitHub repo. So git push and enter, and it is finished. Now if you go to the repo and have a refresh, we should see our new two files created. Here you go. Requirements.txt having Flask, and Docker file having all the required codes. And if you go to the actual repo and see the history, where is it? Yeah, you will see 3 commits here, and the commit I made just now is present here, Docker image creation. So yeah guys, up until now what we have done, let's scroll it up. Where is the image? Yeah. So up until now, what we have done is that we have created hello world in Python, then turned it into a Flask app, and we are continuing to use version control in GitHub, and now we have containerized the application in Docker. So we have created our Docker image, right? But we need to store it somewhere. It is now currently in our local machine. So where can we store it? We can store it in a registry, and Docker has its own registry called DockerHub. Okay, so we can push our image into DockerHub. Okay, so let's start. For that we have some steps. First of all, we need to create an account in DockerHub. It's simply just type in your mail and log in and sign in. I have already signed into my DockerHub, as you can see, and you can see my previously created repositories. Okay, second, we have to create a repo. So let's create our repo. Here you can see a button, create a repository. Click on it. Let's name our repo hello world. Hello world. Okay, fine. We are keeping this public. Okay, and create. It will take a bit of time, and here you go. Now in this step, the most important thing is the name. See this? This is the name of our repo in DockerHub. So it is this. Notice one thing. Okay, yeah, notice one thing, that this is the name of my DockerHub ID, and this is the repo name. And the main thing is that in a local machine, the image name has to be equal to the name in DockerHub. Okay, so in our local image, in a local machine, the image's name also should be this, not just hello world. Okay, it has to match, otherwise you can't push or update your image into your DockerHub account. Clear? Okay, then we have created the repo. We need to create a PAT, that is personal access token, for login. Now we are in our local machine, that is code space, but to use the DockerHub from code space itself, we need to log in, right, with username and password. So giving username and password is not that much a secured way. That's why we use something called PAT. Okay, it is like a token that expires after a certain time. You can use it to log in. So let's create that. Go to your account and click on account settings. It will redirect you to this page, and scroll down and go to personal access tokens. From there, hit generate new token, give a name. Okay, demo key for hello world. Okay, it's fine, we can use that. And this is very important, permissibility. You need to ensure that it has read and write access. We are giving read, write, delete, no matter, and generate. You will see a access code and your personal access token. Okay, so we have the PAT. So let's log in to our Docker Hub using our machine terminal. So first of all, let's copy the login, this command, first one, paste it, press enter. Then it is looking for the password. The password is the token. So press Ctrl V here also and enter. You won't be able to see it. And yeah, login successful. Clear? Okay, now from this terminal, I'm actually using my Docker Hub ID. Clear? Okay. Now, what's the next step? We have logged in into the terminal with PAT. Now, image with the same repo name. I've mentioned this a bit earlier. Our repo name is this. So, if we want to push this, push an image into this repo, we need the exact name. Okay. So let's see in our Docker Hub what do we have. So let's type in Docker images. We have something called hello world. with the tag latest. But we have a repo named this with my name and then the repo hello world. So these two are not the same because it doesn't have my account name, does it? It's only hello world here. So if I try to push it, nothing will get pushed. Clear? So that's why we need to rename our image. How do we do that? We can do this using this docker tag, then write the previous name hello world and then the new name. So the new name is this. Let me write it down. Slash hello world. You can give a version. So let's skip the version for now. Then press enter. And now if you again go to Docker image, you'll see that we have our new image created. Okay, it's just renaming. The previous one is also there, but these two are the same. As you can see, the image ID are the same. Just renamed it. Okay, nothing else. So our repo name and the Docker image is the same name. Now what we can do is just push. So just write Docker push. Docker push. Oh, we need a name. So again, Docker push. Copy this one. If you have a tag, you can add a tag too, but we are not adding any tag, so the tag would be latest. So now press enter, and as you can see, it is getting pushed. And request denied. I have given the access, right? Okay, again, let's see here. It's read, write, and delete, so it should work. Any problem here? So let's again. Oh, I think I have. Yeah. You see, guys, I have misspelled the name. I have misspelled the name. Let me show you. What I have written is this. Okay, my name is Mushfiqur Rahman. There's two R here. See this? But I have given one R. This is why I couldn't push. Just the thing I was saying a bit earlier. Your Docker Hub repo name and your Docker image name has to be the same. So let's again rename this. Okay, let's again rename this. Let's put an R here, so we are fine. Again, let's check all the images. Here you go. Now we can actually push this. Let's press enter, and yeah, it's getting pushed into our Docker Hub. Let's give it a few seconds and it will show up in our Docker repo. Let's see. I think we are about to done. Yeah, we are completed. So the Docker image that we created in our machine is now pushed into our Docker repo. What we can do is just refresh our repo and we should be able to see our image loaded. Let it load, and 1 2 3, come on. Here you go. Here you go, guys. This is our image pushed into our Docker Hub with the tag latest. Clear? And it is pushed less than a minute ago. I just pushed it. Okay. So we are done with Docker push. So what we basically did, our image from the local machine to Docker Hub. So up until now, what we have done is that we have written our code application. We have created Docker image and we have pushed it to Docker Hub, right? Now, assume that I have a new change in my code, new change or update. Then what will I have to do again? I have to again create the Docker image using Docker build and then again push it to Docker Hub. So as we can see, this is kind of a repetitive task. This is where our CI tool, GitHub Actions, comes in. Now, CI, that is continuous integration, basically in a vague term means kind of a automation tool. By automation, I mean if there is an event A, then B, C, D, a chain of events should automatically run. And if there's any error in this pipeline of events, then there will be an error or it will get stuck. Okay, you will be seeing the error messages. Clear? So for instance A, some chain of tasks or events get automatically triggered. This is automation. And also in CI there is continuous integration, that in our code if someone integrates something, we want a task to automatically generate. And for our case, what we want is that if someone integrates something in our code, it should automatically create a Docker image with the new updated code, and it should automatically push that code or image in the DockerHub of our account. Clear? So this is what we want to do with our CI tool, GitHub Actions. For that, let's go to our repo. Here you go. And we need to create a file. So let's add file, create new file. You can do it from the code space or uh, locally and then push it. But here's a hard restriction. We have to use this syntax, GitHub workflows. Okay, you have to use this too. After that, you name whatever you like. Let's name our file ci.yaml. And keep in mind, it will be a YAML file since the GitHub Actions configuration is totally in YAML. Okay, clear? So we have created our workflow file, and again, this structure is a must. .github/workflows, then whatever you file you want to do. Clear? Okay. So now for the actual code. For simplicity, I have already created the code, but I'm just to save time, I just created it early. But I'm going to explain each line step by step. Don't worry. So this is the code, and this is the you can say the main 3 points. First of all, this is the name. This is the name of our workflow, the CI pipeline we want to create. We have named it build and push Docker image. Secondly, we have a parameter called on. As you can see here, on, right? What does this on mean? On means that on what this workflow will trigger. And what do we want? We want it to trigger on a push. If someone pushes, then it should trigger. But push on what? In the branch main. Okay, if you go to the repo, you'll see that this is the main branch. See this? This is main branch. So what I'm saying, any push to the main branch, it should trigger the workflow. Clear? Okay. Then comes jobs. What does jobs mean? Jobs means the tasks that this workflow should make or do. Okay. So let's open that. What tasks do we want? First of all, this is the name of our task. If you have multiple tasks, then you can sequence them after that, and you can do it parallel jobs, sequential jobs. But in our case, since we are targeting for the most minimal stuffs, we are just having only one job. So this is the name of our job, and we have given the name build and push. Next is the machine on which we want to run. Okay, so GitHub is basically giving you a virtual machine for 5 to 10 minutes or whatever the time it takes to run the entire workflow. Okay, it's a virtual machine, and you can specify what system you want to use. Okay, so we can specify here we have Ubuntu latest. Okay, so it will be running on Ubuntu. Okay, fine. Then comes steps. Steps meaning the small steps required to complete that job. Okay, so let's open that, and as you can see, we have 4 steps. First step is checkout code. Second step is log into DockerHub. Third step is creating or generating a tag, and the fourth one is build and push our image. Okay, so let's get to one by one. Let's open the first one. The name of the step is checkout code, and it uses something called this. Okay, action/checkout. What is this? It is something that GitHub Actions offers us. These are something like pre-created actions. Okay, so this is a specific action for checkout. And what does checkout mean? Checkout basically means that, hey workflow, go to my repo and go inside that. It is basically doing these 2 lines. Okay, these 2 lines, nothing else. These 2 lines. Okay, that go clone my repo, or you see the repo, have access to it by using cd. So these 2 lines is basically happening in our this small little actions which we have under users parameters. Okay, okay, fine. I hope it is clear. Let's comment it out. So this is the first step, that our workflow itself getting into our repo. Okay, having access to all of the files that we have for app.py, we have docker file, we have requirements.txt to do the Docker stuff. Okay. Next step is login to DockerHub. So for this, again, we are using a action, this one. Okay, what it does is we just give two parameters here, username and password, and it automatically behind the scene goes to DockerHub and uses these credentials to log in. Clear? And it is all being done on this machine. Okay, this virtual VM. Clear? So as you can see, we need to provide DockerHub username and token. So we're gonna get that a bit later. First, let me show you all the steps. Then comes the third step, that is generate tag. You know why tag is important. And I have mentioned, if we don't mention the tag when creating the image, it will give the tag latest, right? So if all the tags, all the images have the same tag latest, you will be confused. You won't know which tag is when created, right? That's why the best practice is to have tag like version 1, version 2, version 3. So for our simplicity, we are also giving a manual tag, and it looks like this. Okay, it has the year, then the month, then the date, and after that hour, minute, second. Clear? This is, I manually did it, so it becomes more readable. Clear? And what this line is basically doing, it gets this value under this, you see, and stores it in a variable called version. Clear? As you can see here, under that line I have actually printed that example of that variable. Clear? It basically creates this variable, and after creating that variable you actually need to put it in the GitHub environment. That's why basically after creating we just ensure that it actually creates in the GitHub environment itself. Okay, so after going running this part, we will be able to see that version is actually in our GitHub environment and it is present, and we can later on use it. Okay, so we have our tag. First of all, we have the access to our code. The workflow has the access to our code to do whatever it likes. Secondly, we are giving the credentials to log into our Docker Hub. Third, we are creating a tag so we can maintain the versions. And finally, we are going to build the Docker image, and then finally we're going to push it. Okay, so we are using templates because these are again repetitive commands, so we can use templates. So as you can see, we are having Docker Hub username. If you know, I have previously explained that first we need to give the Docker Hub account name, then the repo we are going to push our code to. This is the repo name, Flask Hello. And for the version control, versions, we are giving a version that we created here, at the very last, after the colon. See, after the colon. So these Docker build and Docker push, these two commands are very familiar with you if you have created Docker image previously. So nothing new here. We are just using templating. Clear? Okay. So this was the entire code. Okay. So what I will do is that I'll copy entire thing and then paste it in my actual workspace. Okay. Why is this red? Okay. Let's see. Job ID must contain only alphanumeric. Oh, I guess if I give this hyphen, it should be okay. Yeah. Okay, fine. So we have pasted. Let's skip the tabs. Yeah, fine. So if I just commit these changes, the entire workflow, this one, should run. Okay. So in order to see the changes, first let me show you the repo I have. Okay. So let's go to DockerHub. DockerHub login. I guess I have to log in. Another thing I forgot is that we also have to create a token. Remember, in this we are using tokens. Where it is? Yeah, we are using the username and password here, as you can see, for login purpose. So we also need to create personal access token. So let's create this first, then I'm going to show you the current condition of my repo. So go here, personal access token, then click generate new token, and let's give GitHub CI token. Then generate. Okay, one very important thing, give the permission, give the right permission. Okay. Oh, then generate. I haven't done any expiration date, don't worry, after I record I'll delete it. So here you go, we have the username is this one, the first part. So copy this, then go to our repo, go to settings. Okay, I have some unchanged. Okay, if I commit this change, you'll see that the error first. Okay, since we haven't put in the username and password, so let me show you then. we'll we'll get stuck. Okay, let me show you. So commit changes, It has been committed, so let's go to actions, and as you can see it is running. Click on that. It won't be able to run. Okay, so but yes, as you can see it crashed. If you go inside, click on it and unfold this, as you can see it is stuck on login to Docker. It is still trying, but after a bit it will give you some logs or errors on why it couldn't, but we know that we haven't given the credentials yet. Okay, so we have copied the username. So let's go to the code again. Sorry, let's go to the settings of our repo. Yeah, username and password error. So then go to scroll down here. Where is it? Secrets and variables, select actions, then go to here, new repository secret, click on that, and you have to type in exact what you have used in the code. Okay, exactly the variable you have used. Okay, then paste it and add secret. So username is done. We have username. Now we need actual token, so copy this one. So after that, again new secret, DockerHub token, let's paste that and add create. Now we have our both DockerHub token and DockerHub username. So again, let's go to the actions, and let me again show you the reason of the error. Let's go inside, and as you can see, the error is username and password required. It is not getting it because we didn't even provide those. Okay, so now we have provided. So if I run now, it should automatically give me outputs, or the cycle should run. Clear? But first let me show you the repo. Here you can see that this is my current status in my repo. I have 3 repos here, and for our demo we are using hello world. So let's go inside that, and we have already created the latest tagged image. Okay, now if I run or make any change into the code, the cycle should automatically, or workflow should automatically trigger, and we should see a image with a new tag. Okay, what is the tag? The tag is what we have created here, like this. Okay, and an example is this. Okay, we should see something like this. Let me write it for you. This is the name. Let's see. Then hello world, and then the tag that we created. Clear? I think we are clear on this. Okay, fine. Okay, now for the moment of truth, let's go to the code again. And should I make any changes to the code? I can do that. Let's do that. So workflow is created. Let's go to app.py, and let's change very little. Okay, let's add what to say. Let's, okay, first we have to click on this, edit this file. You can also do it in the code space as well, nothing very important. So let's give this, I am running my first CI pipeline. Clear? So I have made this change. Now if I commit this, we should see our workflow got triggered. So 1 2 3 go. Okay, we have to write a commit message. So yeah, let's go. Okay, it is done, and let's go to the actions straight away. We should see a new cycle being created. Yeah, let's get inside that. Okay, hope it will be running fine. Let's give it a bit of time. We can also go inside that. Yeah, let's click on it. Yes, login is successful, guys. Okay, you see every step, you can see it. Every step you can see that. Here you can see that our actual Docker file is being created and run properly. Sorry, run properly. We have already created this. This is the step 1. Step 2 work there. Remember, guys, this is the 3rd step. This is the 4th step, 5th step, and the image has been perfectly created, successfully created, and then it is pushed. Yes, this is the push command, and finally the push is successful. Okay, so yeah, here you go. Everything's fine. You can see green tick mark, meaning our job, our workflow, our CI pipeline was successful. And in our repo, what should we see? We should see a new version of our image. So it is still not here. We have to refresh that. So let's refresh, and 1, 2, 3, let's go. Come on. There we go. See all. And where is it? Where is it? Where is it? Okay, should be pushed, but where is it? Okay. Everything looks fine, but I don't see the repo. Where is it? Let me again refresh. Have I done mistake? Oh, sorry guys. So sorry. You know what the reason is? Go back. Let's go back to the code. Let's go to the workflows and let's go to the CI. I know I haven't made any mistake. You know the mistake is? The mistake is I gave the wrong repo name. I was working on the for preparation with Flask Hello repo. If you go to my repo, you should see there's a repo called Flask Hello. Let me also show you that for clarification. As you can see, there's a repo called Flask Hello. It was for demo purpose for my practice, and we are working with Hello World. Okay, so if you go to the Flask Hello one, you should see the updated image that we created 3 minutes ago. So we by mistake updated the different repository in our DockerHub. No worries. Let's again rename this. It should be Hello World. Hello World. This also should be Hello World. Very careful about the typos, because if you make mistake, it won't again run properly. So I think it's okay. It's Hello World, right? Let me again check. Hello World. Fine. This time, guys, I promise you it will run. No worries. If I make the commit here, you'll see it. Let's press commit. Here you go. Okay, it started to run. Let's go to the actions. Let's go to the action. It is running. Should run perfectly. Let's go inside. You can see all the steps. Yes. Docker file is running. As you can see. Here we go. I think that image is created and it is being pushed, and we are done. We have the green tick mark. So let's go to the repo and see whether we have a new image. Let's refresh it. And 1, 2, 3, come on. Here we go. Here we go, guys. Less than a minute, a new image has been automatically created. So basically what we have done is that whenever we made a change to our code, it automatically created a new Docker image and then pushed it with a new tag in our Docker Hub. So yeah, this was the CI part up until now. So let's go again to the actual poster. Wait, on the top. What we have done is that we have created a perfect CI pipeline, and with that, our part 1 is complete. So up until now, we are done with this first part 1. Now we're going to do the second part, that is building our cloud infrastructure. We are going to create Kubernetes service in AWS, that is EKS, using an IAC tool called Terraform. So, how to create EKS in AWS account using Terraform. To do that, first we need to have Terraform installed in our machine. To use Terraform and to use AWS, we need to have AWS CLI installed in our machine. So let's do that first. As you can see in my machine, I already have Terraform here, and I also have AWS CLI installed. But if you don't have it, you can just simply go to your browser and type in Terraform install, go to the official documentation, and you will find this. Okay, this for Mac OS, Windows, Linux, whatever you want, and just copy and paste the steps that is mentioned here. Same for AWS CLI, just search AWS CLI, then go to the documentation, and you'll find all the necessary steps that is required to perfectly install your CLI. There's option for Linux, macOS, and Windows. So for my machine, I'm using Ubuntu, so I'm going to use Linux. So it is very easy to install these two. Okay. So after we have Terraform and AWS CLI installed. The next thing is to set up AWS properly. Okay, we have set up Terraform and we're done with that. But for AWS, after installing CLI, we also need to set an IAM user, because what the CLI enables us is that we get to talk with AWS through a terminal using this CLI. Okay, but if we want to talk or work in our personal AWS account, we need an IAM user that is authorized. So we need to configure our AWS CLI with an AWS IAM user. For what it would mean is that whatever permission that IAM user has, you will be able to do it using AWS CLI. For instance, if our IAM user has the permission to create an EKS and you have an IAM user configured in your CLI, then through this CLI you will be able to create an AWS EKS. Clear? Okay. So you understand that we have to create an IAM user and connect that user into our AWS CLI. So first, let's go to the console and create an IAM user. So let's go to the IAM in our console. As you can see, I'm in IAM and users, and let me create an user called demo user. Okay, click on this. Auto generated password or custom password, what to do? You can give the auto generated password for now. Okay, it's nothing. Let's click on create, then go to attach policy. This is important. What permissions you are going to allow this user to have. Reminder that whatever permission this user will have, you will have that permission too if you're using the CLI configured with this one. Okay, so for simplicity, we're going to give administrator access. Okay, as you can see here, it will have everything. And don't worry guys, I'm going to delete before I launch this video, so don't worry. So administrator access, click on next, and here you go, whatever permissions we have, and then create. You can add a tag if you want and create user. So it will take a bit of time, so you can now view the user. You haven't viewed or downloaded this password, okay, no worries. We are going to create an access and secret key. So here you can see, after we have created the user, create an access key, we are going to need these keys to configure our CLI. So click on create keys and click on CLI. We could have done it with the password a bit earlier, you saw. Okay, no worries, we're going to create a new one. And description or tag value, demo purpose, demo user. Okay, let's give it that. Create access key, and now this is the access key, this is the secret key. Another reminder is that if you download this file once or you skip the page, you won't be able to see the secret key anymore. Access key will be available, but you won't be able to see the secret key. So let's download the CSV file. Okay, and let me show you this, since eventually I'm going to delete it. So open it, and here you go. Where is it? Yeah. So I have my access key and the secret key for this IAM user. So let's configure our AWS CLI using this demo user. So let's go to our machine and just type in AWS configure, press enter. Then it is asking for an AWS access key. So copy this access key that we have created for our newly created demo user, copy and paste, press enter. It is asking the secret key, go here, again copy and paste. Then it is asking the region, so we are going to use app south 1. Type in, you can use whatever you are working with. Then default output format, we are going to use YAML. Okay, you can use JSON also, no problem. And we are done. Now our machine is configured with an IAM user. So up until now, again, let me give you a brief summary. We have Terraform in our machine to use Terraform. We have CLI, and we have configured that CLI with an IAM user, meaning whatever this user can do, we can do it too with this CLI. So now we have access to the AWS too. So for the setup part is done. Now for actual code, we need actual Terraform code. So let's go to our browser, and let me show you how we can find the code. Okay, type in uh, Terraform EKS module, press enter, and you'll see there's a link in the Terraform registry for EKS. Let it load. Here you will find all the Terraform modules regarding EKS, since we are building EKS. Okay, now what is module? Module is like a template. Okay, you know template like blueprint, you can reuse them. You have a template, then you can pick this up and create a version 1 of this. By updating this, you can create version 2 of this using the initial template. Got it? This is module. So in module we have pre-created codes of Terraform, and for our purpose in EKS we have pre-created EKS code to create EKS in AWS. Okay, in the Terraform registry, and these are quite popular, as you can see on the right side, that this week these codes were downloaded 1.2 million, and over the entire history all-time record is 127.6 million. So you can understand this registry code is quite popular and everyone is using this. So we are going to also use this, and if you are a beginner, it is a quite easy reference for you, and we are going to use this reference. So we can have quite a few options. We can use EKS managed node group, Fargate, hybrid, carpenter. So all the options are there, but for the demo purpose and the beginner friendly purpose, we are going to use EKS managed node group. So if you scroll down a bit, you will see this is the code for EKS managed node group. Okay, so we have the EKS code here, but EKS needs to run in a VPC, meaning virtual private cloud. Okay, what is VPC? VPC is basically a space in the internet. Okay, this is VPC, which is assigned to you, to your AWS account. Okay, whatever you do in this, it is attached to you and it is private for you. Okay, it's a separate or specific space in the internet or AWS ecosystem for your purpose. Clear? Is a vague definition. So we need an VPC. We need a VPC to place our EKS inside. Clear? So how do you get the VPC code? Again, you can go to browser and type in Terraform VPC module, and you will also get the VPC module from the registry. Click on the link, let it load, and here you go. Yes, so this is the VPC code, and again it is quite popular. If you go, 158.7 million downloads or usage of this template. Okay, so we are also going to use, since we are beginner, we are mostly going to copy and paste this code. Okay, for simplicity. So I've already copied and pasted this code for you. Okay, I'm going line by line, don't worry. If you compare it, let me show you what's the difference. For the VPC part, everything is as it is. Okay, but for the parameters, for AZs, availability zones, I'm using app south, so I'm going to use app south availability zone instead of EU west. The private subnets are also given by me, but the parameters are the same. Clear? Enable net gateway and VPN is also same. We are also going to use tags. Let me show you this. In our code, everything is same. This is the module of VPC. Okay, everything is same. We are also going to create AZs, but it is app south 1A, and here we have our private subnets and public subnets. Everything is as it is, except for 2 lines or 4 lines to be precise. These 4 lines. Okay, so what are they for? Let me explain to you. First, let me explain this part. What is the source? Source is the link from which Terraform would get the template. It is basically indicating this module. Okay, this link. Then what is the name of your VPC going to be? You can do whatever you like. We have chosen as it is. Then the CIDR, you can, if you don't know what is CIDRs, addresses, you can do a bit of YouTube search and know about it, but basically it is a range of addresses. Okay, so you are assigning a range of addresses to your VPC. Meaning, let me show you, I think that would be better. Meaning, let's say this box, this big box is your VPC. This is your VPC. But your VPC needs to have an address range, like from A to B address is going to be my VPC addresses. Like I have 1000 to 2000. Whatever is inside this address in this range is my VPC. So similar to that, CIDR is also a technique of representing addresses from a range A to a range B. So we have CIDR. Okay, so if you want to know further, you can do a bit of research. Inside that CIDR, okay, we have subnets. We have 3 subnets. So it's 3 private subnets and 3 public subnets. Okay, and we have 3 availability zones, as you can see. What availability zones means? In a region, there are lots of availability zones. Okay, suppose this is the big region of App South 1. Okay, it might have 4 or 5 availability zones. Why are they required? They are required for availability. Suppose one of these zones got disconnected or any outages. So if that's the reason, you should still be available. Your app should still be running. That's why we create multiple availability zone. Okay, and put our code in multiple availability zones. So if we have our code in this availability zone, this one and this one, suppose one got closed, disconnected, or faced a crisis, okay, and it is out, we still have to running, and our app will still be running. This is why we choose multiple availability zones. They're placed on different countries, different zones, all within a bigger region. Okay, so this is part of AWS networking. If you want, you can deep dive too. So this is availability zones, and as I've mentioned, we are going to have 3 private subnets and 3 public subnets. What does that mean? So we have VPC, the bigger block, and inside that we have smaller blocks. This is block number 1, and we have 3 of them. Okay, all 3 are basically our public availability subnets, and we also have another 3. Okay, we also have another 3 which are basically our private subnets, and every subnet here are inside this CIDR block, inside this A to B range. All of these also has a number, but this number is within this range. Clear? Okay, as you can see in our code, we have put this CIDR block or CIDR address here, 6 numbers for 6 VPCs, and all of them are under this one. I hope it is clear. Okay, then we are giving enable net gateway true and single net gateway true. What does that mean? The public subnets can talk to the internet directly, but the private subnets can't talk to the internet directly. So what do? They use a medium. They use something called net gateway. This allows them to talk to net gateway, and net gateway talks to the internet. Clear? It is for the security purpose, so that your actual privacy is private and secured. Since you are using private subnets, it is to be private, right? This is why we use net gateway, and by putting a true in front of it, we basically saying that create a net gateway. It is a service of AWS. Clear? Fine. What does this mean? Single net gateway. We have 3 availability zones, as you can see. So for 3, we can have 3 net gateways, but to save cost and demo purpose, we are saying that no, 3 AWS availability zones are going to use a single net gateway, since it is a demo and for practice. Okay, I hope it is clear. Then for the tags, for organizing all the resources. in a good way. It's a best practice. So up until now, everything is as it is in the registry. As it is in the registry, if you look into it. Clear? Okay. Now for the last 4 lines, what does these 4 lines means? As I mentioned, they are very, very important. Public subnet tags and private subnet tags. When are they necessary? They are necessary when you are using load balancers. Now we create EKS, right? We create EKS, and obviously you're going to use load balancers if you want to talk to outside world and distribute the load or requests. Okay, and if you are using load balancers, these tags are a must. Without these tags, your load balancer won't be able to know which subnets are public, which are private. Okay, because there are types of load balancers. Some are internet facing and some are internal. Some handle internal traffic like this, and some handle the traffic from outside. Clear? So it is a must that load balancers know which subnets are public and which subnets are private. And we are just attaching a tag that all public subnets will get this tag, that is kubernetes.io/role/elb, and it is true. So we are using one. And for the private, we have this one. Simple. I hope you get it. Okay. So through these tags, any load balancer we create, it identifies which subnets are public and which are private. Okay. And another thing to be noted, these tags are fixed. You can't change them. Let's say you want to use something else instead of ELB. Okay. No, it won't work. It is fixed. Clear? So this was our VPC module. And another point to be noted, we are using 5.8 version of the registry. What does that mean? If you go to the registry again, here you go, scroll up, here you can see version. See, we are using anything above and equal to 5.8. So anything above and equal to 5.8, it starts from here. Okay, and we are using this version. You can click on it and see the codes too. Okay, we are using this template. Okay, so it is a restriction. And why we are using 5.8? Because it is a bit of older version, and newer versions tend to have bugs, tend to have breakage issues. So it is a better option to have a bit of older versions. Okay, fine. So we are done with our VPC. Basically, we have created a space in the internet to create our EKS inside. Okay, fine. So let's get to the EKS part. So again, let's go to the registry as we have opened a bit earlier. And as I have mentioned, we are going to doing the exact code. So you can just compare this code and what code I am giving here. Okay, it's almost the same, almost the same. Scroll down and you can find the EKS module. So we have the module EKS, we have the source. Again, this is the link to the registry code. The version we are going to use is 20.0. It is very important. Why? Because currently I have opened 21.10.1, and as you can see here, where is it? Yeah, the manage node group code. The parameter here is name and Kubernetes version. Okay, but since we are not using this version of EKS in the registry, we are using 20.0. Where is it? 20.0, this one, right? Let me show you. Yeah, anything above 20.0. So if you look at that, the parameters are different. Okay, parameters are different. Previously you saw name and Kubernetes version. Here it is cluster name and cluster version. Very careful about that, which version of the modules you are using. Okay, so we are using this one. Again, why we are using older versions? Older versions have less tendency to have bugs and breakages. Okay, so same, we have module, source, version, cluster name, cluster version. See here, source, version, cluster name, cluster version. After that we have some add-ons here. Okay, I also have some add-ons. As you can see, what is add-ons, I'm going to explain a bit later. These are the add-ons. In the middle there is a line, cluster endpoint public access. I have also cluster endpoint public access, and VPC ID subnets, control plane subnets, everything is here. VPC ID subnets. I've skipped the control planes one, but you can add them. It is fine. Okay, it is fine. You can add them. And the EKS node group part. I have also have the EKS node group part. So the point that I'm trying to make is that it is almost exactly the same code. I've used this template and just did minor changes to make it beginner friendly. Okay, so that any beginner can copy paste and relate with the registry code and learn how to use the registry itself. Okay, so let me continue with the explanations. So this is cluster name and the cluster version we are using. Cluster version means the EKS version we are going to create in AWS. Another point to be noted is that we are using 1.30, and the updated news is that in January 1.29 version is going to be deprecated. So it is better to use which is still in AWS's development. Okay, so 1.30 would be deprecated in mid of 2026. So we can use this one. But keep in mind that it is still a valid version. After that, I mentioned the add-ons. What are the add-ons? Add-ons are basically the facilities. Like if you have a phone, let's say you have a mobile phone. You have a phone, but is it enough? No. You need to have Wi-Fi, right? You need to have contacts to call and other features like camera, right? Camera. So if you want to use these features, you need to have a Wi-Fi driver inside your phone. You need to have a specific software that will handle all the contacts in your phone. You need to have a physical camera attached to your phone in order to take pictures. Similarly, we add add-ons in our cluster to have various features. Okay, for instance, this core DNS add-on basically handles the DNS part inside EKS cluster, so that every port can easily get the address of other ports. Proxy is used for internal traffic routing inside the EKS. VPC CNI is also used for networking for addresses in the pod. Similarly, EKS port identity has also an advantage. Okay, if you want to know further, you can do a bit of research. Okay, so basically these are some added feature in our cluster. Clear? Okay. Then the next parameter is cluster endpoint public access. What does that mean? We are going to use the EKS from our local machine terminal, right? From here, as we have already configured AWS CLI and added an IAM user, right? So if we don't make it true, we won't be able to use it from another machine. We have to go to the AWS console, then use that console system, okay, to connect with our EKS and use it. So if we give it true, we can use that cluster from any other machine. Clear? Use the kubectl, the HAL, whatever is inside the EKS from another machine using the API or endpoints. Okay. Next is enable cluster creator admin permissions equals to true. This one I added. If you go to the registry, it's not here in the registry. Now what does that mean? It means whenever you have created the cluster, you are done with creating the cluster. After that, there are some steps. Okay, I will be showing with this to you hands-on. After that, you have to set up who has the access to your EKS. So there are some console stuff. Okay, you can also do it with CLI. But what we want is that after creating the EKS, we want to directly use the cluster. Okay, what I'm trying to say is that suppose you have created the cluster. Now you want to use it. But you can't. Why? Immediately after creating, you don't have the access. So you have to go to the console. Then you have to go to the access part. Then create a proper access that has the permission to use the EKS. Okay. What I'm saying is that no, we are not going to do this. We want when the EKS created, we already have the access. We already have the admin permissions. This is why we have given this parameter enable cluster creator admin permission equals to true. Now, is it a good practice? Well, no, but for beginner purpose, for simplicity, for demo, it is good to have a bit of practice. This is why we are going to give this parameter equals to true. I hope it is clear. Then the usual stuffs, VPC ID, and we are referencing our VPC module here, module.vpc.vpc ID, which is going to be created before the EKS here, VPC ID in this module. Clear? We are also going to reference subnets, private subnets we already created, and then comes the managed node groups. Now in EKS managed node groups, as I have mentioned previously, there are quite a few versions of EKS. There's Fargate, which is serverless. There's managed node group where EC2 instances are created. Okay, there's something new called auto mode. If you scroll down, I think we can find okay, in the newer version, it is in the latest version. Let me show you. This is the EKS auto mode. This is something new. You have provision control plane, etc. Okay, so there are different flavors of EKS, but the most widely used is managed node group. Okay, so what it does is that we already have our public and private subnets, right? Yes. So when we set up EKS, it is inside our VPC and it creates EC2 instances in public and private subnets or wherever we define or wherever we configure them. Clear? So this EC2 instance also needs to be configured. Okay, we can't just say use EC2. This is done in Fargate because it is serverless. But since we are using managed node group, we have to define what CPU is needed, how much minimum and maximum it should scale up or down, this type of parameters. Okay, this is why we are using this block called EKS managed node group, and we are defining which instance type it is going to be using. T3 medium, it has its CPU, GPU, memory configurations. Okay, what minimum size and maximum size we are going to use, it is 1 and 3, meaning in our EKS cluster there will be one EC2 running always minimum, and maximum it will scale up to 3, and what is the desired is 2. If it is possible, it will keep at 2 EC2 instance running inside the cluster. Clear? After that, we just have tags. We also had them previously. So this is the entire code, guys. I have basically copy and pasted from the registry code and made the slightest of change, these 4 lines, and I just added this line, 5 added lines, that's it. Okay, and in the very top is the Terraform part. What it is saying is that in required version, what Terraform version we are going to be using. Why it is necessary? Because it ensures a restriction so that you are not using a Terraform version 1.2 or lesser. Okay, so that a boundary or a certain condition is filled. No one is running what in whatever Terraform version you want. Okay, so this is to put a restriction on it. After that is required providers, meaning which cloud provider you are going to use. We are going to use AWS, and we have put the source of the module or the code that Terraform would be getting the code from. This is the link. This is official. Okay, don't worry about it. We also mentioned the version, which version of the AWS module or provider it will be inputting. In the provider block, we are just going to add a bit details of the AWS. Since we are using region app south 1, we just added there. Okay, so this was all about the code. Okay, I've explained each and every line for you guys. So let me copy this and let's go to our machine. Okay, let's create a file called main.tf. Okay, and let me paste it. I have pasted it. Clear? Don't forget to Control S to save this. Clear? And then let me make it bigger. You have to do Terraform init. Press enter. What will this do? It will pick all the provider modules and whatever stuff that is needed to run this code. Okay, so press enter. Initializing backend, initializing modules. It is going to the registry, getting the AWS provider, downloading anything that is required, matching all the versions. As you can see, it will take a bit of time. Let's wait. Still installing and done. We are successfully initialized Terraform. Now after that, the second command is Terraform plan. Terraform plan. What it does is that it gives a list of resources that it will create for us. A plan to be exact. So enter. Let's see what does this give. It is checking and it has given us a whole bunch of lists. What it is going to do, everything. We can check this out. We can even save this because Terraform is going to execute everything that is mentioned here as it is. Clear? So it's lot of resources. I think in total 65 resources in total. Oh yeah, 64 in total. Okay. Now for the final command, that is Terraform apply. Are you ready? So Terraform apply. You can also add auto approve since it will ask to confirm. So first let me show you the confirmation also. So it will start when I press enter. Okay, enter. Since I have not added the auto approve tag, it will ask me for confirmation. Yes, enter a value. Yes, if I type in yes, and it will start the execution. Ready? And enter. So the execution has started. And let me give you a disclaimer here. EKS takes a lot of time, and it will take almost about 15 to 20 minutes to set up every resources that I have mentioned. I have used the most minimal possible code, but still it will take 15 to 20 minutes. So be very patient, and I'm going to pause the video here, and after the EKS cluster is set up, I'm going to show you the next steps. So after almost 15 minutes, we are done. Apply complete, resources 64 added. Okay, and it took a lot. Okay, few resources, as you can see, 9 minutes 20 seconds, and like this it almost totaled up to 15 minutes. Okay, so let's go to the console and see whether our cluster is created or not. And here you can see my cluster is created. Okay, so let's see whether from our machine can we run the EKS cluster. So let's say kubectl get nodes. If this runs, that means we are okay. Pressed enter, it didn't run. Why? Because after creating the EKS cluster, we need to initialize it. Okay, how to do that? You have to run EKS, AWS EKS, then update kube config, enter the cluster name, that is my cluster, press enter, and now we are ready to run kubectl. Okay, so again let's see that nodes, kubectl got nodes, and here we go. We have 2 nodes created and we are now into EKS. Okay, now if you are not using this line, that is this line, if you are not using enable cluster creator admin permissions, then after running this line here, that is update kube config, you won't be able to run any kubectl commands. But since we have made it true, that's why automatically after creating the cluster, it is giving us the admin permissions. Now if we don't do it, what is the steps? Then you have to go to the cluster, enter your cluster, go to access, and you have to create an access. Okay, here you go to access, then scroll down, and here should be an option here, IAM access entries. So you have to create an entry for that. Okay, you have to give your IAM role here, whatever you have created, and follow the steps to ultimately create an successful access. Okay, clear? Okay, fine. So guys, before we get into the conclusion, if you want to destroy whatever you have created, the command is terraform destroy. After that, you also need to approve and type yes. Okay, then disclaimer, it takes almost 15 to 20 minutes to destroy. Clear? So be patient with the destroy as well. And a very important thing to notice is that if you have any load balancer in your resources in the EKS cluster, please delete those resources first or change the type to cluster IP, okay, before you run the Terraform destroy. Why? Because if you remain the load balancer and type the Terraform destroy, after running 5-6 minutes you'll get an infinite loop. Okay, the Terraform would try to delete every resources that it created, but it will fail due to dependency. Okay, many of the resources, like load balancer would say I am attached to a resource. Okay, I'm attached to a resource, but the resource doesn't exist. Okay, so it can't find a resource here and it can't be deleted also, so it will get into infinite loop. So it is a quite a bit hassle. Please, before Terraform destroy, make sure you have changed the type to from load balancer to cluster IP or deleted the resource itself before Terraform destroy. Okay, if you did that, then everything is fine. It will take almost 15 minutes to destroy if you are using my code. So here you go, guys. We have successfully created an EKS in our AWS account using Terraform. Forgot one thing to mention is that up until now I have shown you how to create the access in the cluster using the console. You can do it with AWS CLI commands too. You can run this create access key, access entry, and then associate a policy to your access. Okay, so you can do this also. So up until now we have successfully created our cluster. Let me again show you that kubectl get nodes, and here you go, we have all of our nodes. Okay, now let's do a deployment. Remember we have created a Docker image. Let me show you this one. Let it load. Yeah, we have created hello world Docker image previously. Now we want to deploy it in our EKS. Let's do that. Now what we are going to do is that, let me give you the theory first. We have an image, right? We have an image. When we run the image, what is it called? It is called a container. So we would be converting the image to a container. Okay, now after we have converted the image into a container, then we need to install it in our EKS system. How to do that? For that, what we are going to do, we are going to take this container and we are going to wrap it up in another box which is called pod. Okay, it is called pod. And we are not going to stop at that. What we are going to do then is that we are going to create multiple pods of it. 1, 2, 3. 3 replicas. Okay? And these replicas are called together a set which is replica set RS. Clear? Now, what is this RS for? RS is for if any of the pod gets down, it will instantly create another pod to replace that. It will always maintain a number of replicas. Let's say if we have replicas of 3, then it will make sure that in our system in EKS always there are 3 pods running. No matter if 1 loses, 2 loses, it will instantly create to replace them. Clear? This is replica set, and the container we have wrapped, the wrapping is called pod. It is the minimum unit in Kubernetes. After that, we will have another wrapper of the entire thing. This is called deployment. Clear? Okay. Now what about the service? Service is basically we are connecting these all of the replica sets together, and we are having an output, a hand outside. Okay, so if we want to talk to these pods, we are going to talk to this endpoint here and we'll be able to connect with any of the pods. So if our hand that is sticking outside, if it is connected to the internet, then we would be able to connect to these pods from the internet. Clear? So this is the container, then pod, then replica set, then deployment. Now the interesting part is that if we create the deployment YAML, to create any resources in Kubernetes we need YAML files, YAML configuration files. So if we just create deployment, we can create all of the things in between. Okay, the pods, the replica set, all will be created automatically. So we just need to create a deployment script. Okay, so I have created that for you. Let me show you and let me explain the rest of the part. Where is it? Here you go. So first we are going to start with our image. This is our image. So let me actually copy paste the actual one so that we don't get any typos. Copy and paste it. So this is our image. Okay, and this is the container part. The image is now turned into a container. Got that? And it is having a port 5000. Remember that our image has a port 5000 as well. Okay, let me elaborate. uh, the image has a port called 5000 and it is mapped with the port of the container which is also 5000. Clear? Container. So we have the image created inside a container. Now what's the next wrap? The next wrapper is pod, and pod is the minimum unit in Kubernetes. This portion is for pod. Okay, under the spec we have the container part, and above that we have the metadata of pod. Clear? We have added a label, app hello world. Okay, I'm coming to that a bit later. So the entire thing of the pod is inside something called template. Clear? Template is basically indicating your pod and its configuration, and under the pod you have the container. Under the container you have your image. I hope it is clear. Now if you go above, there's something called selector, and there's something called match labels. What is it doing is that it is matching labels. It is matching these labels. Whatever pod that has this exact label, that is app hello world, it would attach to that. So for our case we have hello world here, as you can see, matching. This is why this is able to catch this pod for the labels. Clear? Okay. Then there comes replicas. This is for the replica set. We are ensuring that there would be 3 replicas all time present in our system. Okay, the replica that I have mentioned here, 3 replicas, 1 2 3, 1 2 3, right? This is the parameter that we use to do that. Above that is our the final layer or final wrapper, that is deployment. And for deployment these are the metadatas. These are the metadatas of deployment itself. This is the name of the deployment, same as the rest. This is the namespace where it would be creating, and this is the label for deployment itself. Clear? So guys, you've seen there are multiple wrappers. First we had image. The image is inside the container is inside the pod, and we have created multiple pods, 1 2 3, which is called replica set. The replica set is in another wrapper, that is deployment. Now you might be wondering why deployment. Deployment has its own features. It is helped in deployment itself. Okay, there are lots of strategies for deployment, and it basically handles that part. After that I have another thing called service. Okay, I have below that I have created the service part. Now as I've mentioned, what service part does is that it enables us to talk with our pods, right? So we need to ensure that the service is properly mapped to the pods, right? So how we did that? We did that again with something called selector. Okay, we are again mapping app hello world, and whatever pod that has this label would be connected to this service. So which pod does have app hello world is this app hello world. Okay, so the service would be mapped automatically to our 3 pods. Clear? Okay, fine. So we are done with the pod selecting, and if you go below that there are pods. This is for service itself. I have mentioned there is a hand sticking out, this one, this part. This is the part of the service itself. Okay, if you go under that, there's a protocol. You can define a protocol. Here it is TCP. You can give a name for the port as well. It would be handy later on. You can reference the name. You don't have to reference the port later on if you give it a name. Okay, the target port is the port of the pod or container. Okay, the container port is 5000. Remember, I've shown you here the container port is 5000. So we are mapping that port again. Okay, so we are mapping that port to, sorry, to port number 80. Clear? So now the service would have the port 80. Clear? This is now the port of the service. So whenever we call the service port 80, it would map to the container port 5000, which will map to the image port 5000, and we would be getting an output. Clear? Okay. So the rest is fine, and this is the type cluster IP. If you know, there are three types of services: cluster IP, node port, and load balancer. So this is a cluster IP type. Clear? Okay. So this is the service YAML, and above that we have the deployment YAML. So let's go to the deployment in EKS itself. Let me copy this. Let's go to our environment, and let's create a file called deployment.yaml. Fine, and let's paste it. Don't forget to Control S to save this. Done. Okay, now let's go to the terminal. Let's create an alias k equals to kubectl so that the typing takes less time. Now k apply -f deployments. Okay, when we press enter, it should create our deployment and the service. Let's go. And deployment has been created and the service also been created. And I've mentioned whenever we create the deployment, pod would be automatically created, replica set would also be automatically created. Let me show you. Okay, get all. It will show everything that is present in our default namespace. So here you go. Pod is created, 3 pods created. There are okay, replica set is not present here. Oh, I'll be showing you that. Wait, there are 2 services. This one was previously created by default when we created the EKS itself. This is our service, one service. Okay, and this is the deployment. And oh yeah, replica set is present here. Replica set desired 3, since we have mentioned 3 replicas. Clear? So guys, we have successfully deployed our app in EKS system itself. Now if you want to see our image, we can port forward to show you port forward. And how to see the port, I've mentioned it a bit earlier. You can see the port if you click on this. If you click on this port of the service, it would map you to the port itself. Like I have said here, if you click on the service port 80, it would direct you to the 5000 of container, which would direct you to the 5000 of image. So let me click on that service port, svc slash, what's the name? The name is hello world service. So let me copy this, hello world service. Then the machine port, let me use machine port 80,000. Okay, this is not the service port, the service port is 80,000. The machine I'm working on, let me show you again. I'm giving it another wrapper here. Okay, I'm mapping machines 8080 port. Okay, it is my machine that I'm working on. Clear? My machine. Okay, so the machine would map to the services 80 port. So let's go. So first port is the machine's port, then colon, then the services port. The service port is 80. Here is, you can see 80. Clear? Then you press enter and you should see our port has been forwarded and we should see our app on the browser. Click on it. Okay, and this happens in code space, nothing to worry about whenever you do port forward. So, most often it redirects you to another code space and then you have to type in the port. Okay, so I don't know why code space does that. I think it's a network issue or something. Okay, but as you can see, our port has been forwarded and it has been created. Okay, so let me click on from here to see if it loads. Okay, so nothing to worry, if you using your local machine, you instantly get the result. Okay, but in code space it takes a bit of time, I guess. So it is still low. So guys, I think it was a network issue, but finally it loaded. Okay, hello world that we have created in the image. Okay, the image also had another endpoint, if I'm not wrong. Let me show you. That is /new. So we also should see the /new. Okay, if it is in our latest image, then we also should have /new. Here you go. I had the message, I am running my first CI pipeline. Okay, I had this message. So guys, we have successfully deployed our image, our app. The app is inside the image, right? Into a deployment environment, a production grade environment, that is EKS. Okay, so we are done with our part 2 properly, entirely. Now let's go for the part 3, that is observability. So why use Prometheus? We have our EKS cluster, right? And in the EKS cluster, we have our application running inside a pod, right? But in DevOps, just having an application deployed in EKS, is it enough? Is it? No. But we have to also monitor them. Okay? And how do we monitor? We monitor them by seeing metrics. What does metrics mean? Metrics means various kinds of parameters like CPU usage, resource usage, there's latency, there's request per second, etc. By seeing these matrices, we can monitor our EKS and our application and see or decide what to do, whether everything is healthy or not. This is done by Prometheus. Okay, Prometheus basically gets the matrices from our EKS and application, and we get to see them. Clear? Fine. But how to install this Prometheus? We install Prometheus using something called Helm. What is Helm? Helm is a package manager for Kubernetes, like we have pip for Python. We install different Python libraries with pip, right? Pip install Flask and everything. Similarly, we use Helm to install any third-party software inside our Kubernetes. Clear? So it is a package manager. So to use that, first we need to have Helm installed in our machine. So let us write version, Helm version, to see whether we have it. We have it. We have installed it, and in code space, it is given by default. So nothing about installing. So here you go. We have our Helm. Then what we need to do is install Prometheus itself. To do that, I have already written the codes. Let me show you here. Where is it? Prometheus. Yeah. We need to run these 3 lines. But what do they mean? Basically, in the first line, we are just installing a repo in our Helm. Helm repo add. We are just adding it. This is the repo name, and this is the link. If you click on this, you'll see it will redirect you to this page, and you can scroll down and go to the GitHub page. It is a repo where all of the Prometheus related charts, Helm charts, are present. Now, what is Helm charts? Helm charts are basically a template. Okay, these are basically a template. Like, this is a template, and you can use them in your EKS to create resources. So the template might have 3 pods, 3 deployments, etc., etc. And you can just run the Helm chart, and you will see all of the resources inside that Helm chart present in your EKS system. So it is a template. Clear? Okay. So for Prometheus as well, we have Helm charts, and all of the Helm charts are in this repo. You can find it here. And in the second line here, we're basically updating or refreshing our Helm, refreshing all the caches behind the scene, etc. Clear? It is very simple. After that, we are basically installing Helm install the specific chart that we need. In the repo, there are lots of charts, but we need this chart, and we are giving the name of this chart Prometheus. Clear? Okay. And this names is officially called release name. Okay, release name. And we are also mentioning to create that Helm chart in something called monitoring namespace. And we have added another tag, that is create namespace, meaning if we haven't created the monitoring namespace, it will automatically create that for us. So I think we are clear on these 3 lines. So let us copy this, and let's go to our machine again and paste them. And we would see that Prometheus is being installed. It will take a bit of time, so we can wait for that. So we have installed Prometheus. Okay, so now if you do kubectl get namespace, you'd see monitoring is already created automatically. And if you see what the installment has created, you can type in kubectl get all, enter the namespace, that is monitoring. Sorry, there's a typo. Monitoring, press enter, and you'll see that the Helm chart has been created, it has these services, it has these deployments and everything else. Clear? Okay, okay, fine. Now what we have until now, we have installed Prometheus. Now will Prometheus be able to track them, trace them? No. For in order to trace our app, we need to have metrics created for our app. If the matrix is not created, Prometheus won't have anything to scrape, right? That's why we need to have an endpoint like slash metrics or anything which will have the matrices of our app. Clear? But now, until now, we don't have anything like that. Until now, we don't have anything like that. So how to create matrices of our app? To do that, we are going to add a few lines of code. We are going to install these libraries. So we can copy and paste them in our requirements file, requirements.txt here. Copy and paste them. Here you go. Both of them are required because I only tried with Flask exporter, but it didn't run. Okay, so the second one, that is client one, is also important. After that, Control S to save this. Control S. So now we have the necessary libraries. After that, we have to call the libraries to make sure it traces the matrices, right? To do that, first of all, we have to import this tool. Okay, let us paste this one. We are importing from Flask exporter Prometheus matrix. We will be using this tool to have the matrices. After that, we also need this line. Let me paste it here too. What it does, behind the scene, it automatically creates slash matrix endpoint, and in that endpoint we will have all the matrices regarding our application. Okay, I will show you the endpoint as well. Okay, let us Control S to save it. After that, let us push the code in our GitHub repo. Okay, and we know, since we have created our CI pipeline, whenever we do any push, the CI would create a new image, right? A new image would be created, and we would be able to see it in our DockerHub. So let me show you the current scenario in the DockerHub. We have created hello world image, and it has these tags. Okay, the latest one was created 30 minutes ago. I did it for practice. Okay, nothing to worry. Now again, let's do the git push. First of all, let's git add, then git commit. Type in a commit message. What matrices are added in app.py. Done. We also change the requirements file, right? Press enter. After that, do git push. After git push, we should see that the changes are in this file. So let's refresh this, refresh the repo, and here you go. These two lines are added, meaning our application is now having an endpoint called slash matrix, where we will be seeing all the matrices of our app itself. The requirements file also should have the two libraries installed, and since we have a CI in the background, automatically it started, it also finished, and as you can see, it has created a new GitHub Docker image, okay, and pushed it in our DockerHub. So if you go to the DockerHub and refresh, you should see the new one. The latest one has 420, and let's refresh, and here we go. Yeah, 2 minutes ago, and the latest one has 706. See, so let's go inside, and since our deployment has a different tag, okay, it has 633, so it is a previous version of our image. Since we have updated this, we need to update this image as well in order to use it. So let's copy the name, copy it, then change this one, copy paste 706, clear. Control S to save it. Then since we are already in EKS, now it is time to deploy. Let's clear this screen, clear the terminal, and let us also add an alias for our efficiency. K apply -f, then deployment. Clear. You'll see that it is configured or changed, okay, or created. Okay, since we have created it for the first time, I deleted the previous one. Okay, so it is created with the image, this one we just created a bit earlier. Clear. Now if you want to see that whether the slash matrix endpoint created or not, I can also show you. Let me first show you the services. Here you go. Hello world service is running on port 80. Let me port forward to show you guys. Port forward. As we see, the name is hello world service. Let us have the machine 8080 port, sorry, 8080 port mapped with 80 port of the deployment, sorry, service, and press enter. We should see the pop-up. Open in browser. Now if the network is slow, it will open a new code space, then we have to click on it. Otherwise it should immediately show our result. So it is actually opening a new code space. It happens in code space. Don't worry guys, it's not an error or something, it's a network issue. So from here let us again click and hopefully it will load this time. Okay. Here you go. Hello world has been showing. So if the new image has been loaded in our system, we should see a slash matrix. We haven't added any slash matrix, guys. Let me show you the code. uh, Come on, load. We have a slash endpoint and we have a slash new endpoint, but no slash matrix endpoint. It is automatically generated through this line. Clear? So since we have already created that, we should see the slash matrix endpoint as well. So let's write slash matrix and enter. We should see all the matrices of our app generated. So let it load. And here you go. All of the matrices are present in our slash matrix endpoint. Clear? Okay, fine. So let's stop it for now, or let's keep it running. Let's create a new terminal. So up until now, what we have done is that we have installed the Prometheus. We have created an endpoint slash matrix that has all the matrix endpoints, sorry, matrices. Now the next thing is that we have to tell Prometheus go to this port and collect the matrices. Okay, if we don't tell Prometheus to go to which port, it won't know to which port to scrape. Okay, to do that we have a few options. First one is to edit something called prometheus.yaml and manually add the pod name, or we can use something called service monitors. Service monitor. Now what is service monitor? It is a CRD. You don't need to know CRD. If you wish, you can do a bit of search, but in a vague term, it is a declarative way to tell Prometheus to go to this port and scrape. Clear? For that we have to write a separate YAML manifestation file. So I have already written it here. Let me show you. Here you go, and it has its metadata here. This is the name. This is the namespace where it would be creating. It would be created in monitoring, and this is very important, the release. Okay, since we have added a release name when we install Prometheus start, right, we have to make sure that this release name exactly matches that. This is saying that this service monitor would get attached to that release name. Clear? Fine. Next we have a selector. It is basically selecting a service. Clear? We have hello service, hello world service for our pod, so it is mapping that, it is selecting that with this label. After that it has an endpoint to scrape. Okay, let me elaborate a bit. I have here to make it a bit easier. Side by side I have the service monitor YAML and the service YAML for our hello world. Okay, so this is the release name that I mentioned. It has to be exactly as the installment. It is selecting with this parameter app flask hello, and it is mapping to the metadata of our service. Okay, if this matches, then the service monitor would get connected to this service, and this service is connected to our pod. Clear? Secondly, this port name is already present, that is HTTP. It is a manually given name, you can do whatever you like, and we are just calling this name to get endpoints from this. Clear? This is the port on which the image or container is running. Okay, fine. And we have the slash matrix endpoint too. So we have to map these parameters in order to actually perfectly attach the service monitor to scrape this service, and by meaning service we mean the pod itself. Clear? So let's copy and paste and add to our system. We need to add a file, so let's type in service monitor.yaml and paste it. Let's Control S to save that. Then kubectl apply -f service monitor. Okay, and press enter. It is created. So the service monitor has been created in our system. Clear? Okay. So we have set up Prometheus, we have set up the matrices for a pod, and we have told the Prometheus to get the matrix of a specific application or specific pod. So how do we see that? We can see it from the service of Prometheus itself. When we have installed the Prometheus, we saw that these services were created. Okay, if we forward any of these ports, we would be able to see the matrices. Clear? So let's do port forwarding. The UI is in this service, Prometheus kube Prometheus Prometheus. Okay, and it is in port 9090. So let's port forward that. Let's do kubectl port forward. It is in the monitoring namespace. Storing svc. What's the name? Let us copy paste the name. Here you go. Copy it, then paste. And since it is in 1990, we can also do 1990 for our machine. Let's map it 1990 with 1990 and enter. Okay, I made a typo. Sorry, my bad. Okay, fine. So the port is being forwarded and we should see a pop-up. So it was a bit of network issue from my side, but finally we are stable. Let's open the port forwarded 1990 and let's see what is the result. Here you go, guys. We have launched our Prometheus URL. Now if we have successfully mapped our pod with Prometheus, then we should see that in target health. Ready? 1 2 3 go. And here you go, guys. Hello world SM service monitor is perfectly running and it is showing 3 pods: pod number 1, pod number 2, pod number 3, and all of them are running fine. State is up, and if I collapse this, you'd see everything. Okay, let me collapse. Yeah, everything is green, everything is running. So that means we are successful. We can see the metrics by clicking on this. Okay, and there are other details as well. So we are successful in creating and tracing the metrics from Prometheus. Clear? Okay. Now, okay, one more thing is that we can even query the metrics. Okay, you can write any queries and it will show you a result. Clear? Now for the Grafana part, why do we need Grafana? We have Prometheus and we can trace the matrices. Now if we want to see these matrices in a nice dashboard, okay, nice dashboard, then we need something called Grafana. Grafana is a dashboarding tool, and we can have the source as Prometheus to see the Prometheus matrices. Clear? So how to do that? Let me show you. The interesting part is that when we installed Prometheus, if I scroll up, you'll see that automatically Grafana has been created, and there is a service called Prometheus Grafana. So we don't need to again install Grafana. It is pre-installed and it is in port 9090, 1994 as well. So if you scroll up, you'll see that get Grafana admin user password. So when we open the UI, it will ask for a password. So let me copy this and get the password, paste it. This is the password. And now let us keep forward, port forward the uh, Grafana UI as well. It is in monitoring svc, and it is, what's the name, Prometheus Grafana, if I'm not wrong. Prometheus Grafana. Let's copy it and paste it here. We have the port 9093, right? The second check, it's 9093. Let's map it to again 9093 and enter. Okay, does not have port. Have we made any mistakes? Sorry, it's 80. My bad, guys. This is the row. It's port 80. So nothing to worry. Let's write 80. Press enter and we should see that the port has been forwarded, and after a bit we should see it. Okay, again a bit of network issue. So the port has been forwarded, and as we can see in the port slow, so let's click on this and we should see the Grafana UI. Okay, so as I've mentioned, the Grafana UI would ask us for this password and there would be a username. So let's see. As you can see, Grafana symbol is jumping around. Let's wait a bit more until we have the login page. There you go. So the username at the first would be admin, and the password is the password we just copied here. Here you go. We just copied this one and paste it here and then log in. We are successfully logged in into Grafana UI. Now, how to create the dashboard? Go to dashboard, click on the plus and import dashboard. Okay, import dashboard, and in this we are going to give an ID 3662. What does it mean? It means that Grafana has pre-created template of dashboards. So if you write Grafana dashboard templates, you'd see that a link has lots of pre-created dashboards for Grafana. So you can explore a bit, and each of the dashboard has their own ID. So one of the most popular dashboard has an ID of 3662. So we're going to use that. So press load. After that, scroll down and you can see there's option for the input. Okay, this is the name. This is the name of our dashboard, and click on this. This is the default one, and when we create import we should see an amazing dashboard that has our Prometheus matrices from here. Okay, let it load. Yeah, so are you ready? 1 2 3 import. So here you go guys, we have a perfect dashboard created. Okay, a perfect dashboard. As you can see, there are all of sorts of matrices. Okay, and when you hover over any of them, okay, you'd see the Prometheus promql query. If you can copy that and paste in the query section here, you'd see tables or graphs as well. Okay, and the Prometheus is already providing us with the dashboard. So also let me show you the uh, port of our actual app, which was port forwarded. This one, whenever I click on it, make queries, you will see that this change. Okay, so currently I'm here. Let me refresh again, 2 times. Okay, again, let's see. Here you go, and it is refreshing. See the number changing, the number is changing. Okay, so if you have lots and lots of requests, lots of usage in your application, you'll see that continuously this chart is changing and it is refreshing every 30 seconds. So here you go guys, we have successfully created a Grafana dashboard. We have installed Prometheus and Grafana together. We have created an endpoint called metrics for our app. Then we have created a service pointer so that Prometheus can stick to an app and get the metrics. And finally, we showed them in our Grafana dashboard. So this was for our part 4. So we are going to use ArgoCD for continuous delivery. What does continuous delivery mean? We have our code in our GitHub, right? Now, continuous delivery means whenever we make any changes to our code, it will automatically change in production. Let's say we have 3 replicas of our pod, right, in our code. Let's say we have changed it to 5. Then what we would see that automatically in production, the replicas has also changed from 3 to 5. This is continuous delivery. Okay, and what we are going to use for this is called ArgoCD. It is one of the most popular CD tools. Okay, but one thing to remember is that ArgoCD doesn't just track the code, the entire code. It tracks the code of YAML manifestations. Okay, the YAML files or YAML manifestations that are related to Kubernetes, ArgoCD only tracks those. Now we have app.py, right, for our application code, And we also have deployment.yaml for our Kubernetes manifests. So basically, whatever change we do here, Argo won't pick it up. But if we change anything here, Argo would pick it up and change the production accordingly. Clear? So what can we do here? Can we connect the both? Yes, we can. We know that whenever we do any changes in the code, it creates a new image, right? And we know in the deployment, there is a parameter called image where we put the image name, right? So if we have a new image due to an update, and if we don't have it in the image tag in the deployment, our production won't have that image, right? It will have some older version, but not the new updates, right? We can minimize this using our CI pipeline. We already have a CI pipeline, right? So we can extend that so that whenever we have a new image created, we want that it will change the image tag and replace the old with the new one. Clear? Whenever we have a new image with a new tag, we want that old one would be gone and the new one would be replaced in this parameter. And whenever there's a change, like we have a new parameter in the new value in the image parameter, this would trigger our ArgoCD. So this is our aim. So how to do that? For that, first of all, we need to change our CI, which we already have created. Second, we need to install ArgoCD, right? Then we need to set up an application for ArgoCD to work. So let's go do the first step. If you go to the repo, we already have our CI. Let me show you. Let's open this. Okay, a bit delay here. Never mind. Let's go to from here. ci.yaml. We have it here. Okay. I also have it in my local files to show you guys the changes. So up until now, what we have this. The name is build and post Docker. We have the trigger and we have 4 steps. This is the first step, right? This is the second step. This is the third, and we have finally the fourth one. Where is it? Uh, okay, there's a bit of okay, never mind. I think it's a bit of copy pasting issue, but nevertheless, I can show you from here. We have 4 files, 4 steps actually. First step, second step, and where's the third one? This is the third one. Okay, and this is the fourth one. So let me clear the terminal for now. So we have 4th step. Check out the code. What does that mean? I've explained previously. It basically allows GitHub Actions to clone the entire repo and get inside the repo so that it can work with it. Okay. The second step is that it will log in with this credential. The third step is that it will create or generate a tag to use for Docker push. And in the final step, we basically Docker build a new image and then push it into our DockerHub. Clear? Now, what changes will we be bringing to for our CD? Okay, we are basically going to do 2 things, and the major part is this. We are going to be adding a new step. So in this step, what we are basically doing is that we are making the change in the deployment.yaml with this line. Okay, in this line, what are we doing? We are basically using this what function, you can say, in Linux. What it does is it searches for a tag and replaces them. We are using -i, which means we are doing the changes in place. If you don't use this, you'll see that it will show the changes in the terminal, but it won't be making the changes actually. So we are using in place changes. Then we are searching for a tag, image colon. Okay, and we are changing anything like this that has this value, okay, in the deployment.yaml file. Okay, so we are changing the old tag with a new tag that we have generated in the previous step. Where is it? Here you go. We have the value here, see, and we are changing this like this. Clear? Okay, fine. Then after this line, we have these 2 lines. These 2 lines are basically meaning we are again logging into our GitHub. Okay, for that we need something. We need a token. Without a security key or something, we can't just log into a GitHub, right? So when we had the checkout step, what we did, we just get into the repo and enter into the repo, right? With that, we are adding these two lines. Okay, token. This token means that a token would be automatically generated to use later on, and this is an extra, you can say, patch depth 0, which basically means the GitHub Actions would have an overall idea of the entire repo. Okay, you can skip it or comment out if you wish. So that line basically enabled us to use these two lines. Clear? After that, the regular add commit push, we are just adding the change deployment.yaml, the changed one, into the staging area. Then we are committing it and we are pushing it to our GitHub again. Now, understand one thing. We are changing the uh, app.py, then adding the change in our deployment.yaml. That means another change has been added in the GitHub repo, right? So the CI should again run, right? And it means an infinite loop. So if we do that, then resulting an infinite loop is not what we want, right? To stop this infinite loop, at the very beginning, we are going to add two lines. That is path ignore deployment.yaml. So whenever there is a change in deployment.yaml, this workflow or this GitHub CI pipeline, build and deploy image, won't run. It will only run if there is any change in the main branch, but except for deployment.yaml. This is for not to get the infinite loop, because we are going to change the deployment.yaml, and if we don't do this, changing the deployment.yaml would again trigger a new workflow. Clear? So these are the changes that we are making. First of all, we are adding this step. Secondly, to actually get into the repo and make change, we need to use a token. So we added this, and to avoid the infinite loop, we added these two lines, path ignore. Clear? And the rest are same as it is. So let's copy. Let's go to our machine, and where's the terminal? Let's go to the CI and paste it. Okay, so we have successfully pasted it, and Control S to save that. Control S. Now what we can do is git add, git commit. Let's add a message that CI is changed for CD. Okay, now when we push, this cycle would run. Okay, to actually know that change, let me show you the current deployment YAML. Currently the deployment YAML has something with 633. Okay, now if we rerun it, it will create a new image, and that image would be with a new tag included here without any manual interaction. Okay, it would be automated. So are you ready? So let's do the git push and run our CI. Enter, and let's see, it is pushing, and yes, the push has been enabled. And if we go to the actions, we should see that our CI pipeline is running. See, CI changed for CD. Let's go inside, let's click on it, and let's see whether if we get any error or not. Successfully pushed, and this is running. Okay, successfully done the changing part, and yes, it's a green tick. So are you guys ready to see whether the deployment has changed or not? The image, it was 633, right? I haven't done anything. So let's again go back to the deployment. Here you go, and we should see a new image. Scroll down, and here you go, guys. 450, the new image. If you go to the DockerHub again, let it load, we should see the latest tag image. Okay, let us go back, and here you go. Okay, it hasn't been yet loaded. Let us refresh, but it will come here. Okay, no worries. 450, this is the new automatically added tag. Okay, this means we are successful. We are successful in creating that. Okay, I think there's some kind of error. Let me check the name. Oh yeah, I made an error. I have written Flask hello, but the repo we are looking is hello world. My bad, guys. So let's again push it. Let's again push. I've made the wrong name. This not Flask hello, it is hello world. So let us replace everything. Sorry. Here you go with hello world. Hello world. And apply. So every Flask hello has been changed. Okay. So we again have to do this step. Control S to save it. And let's again do git add. Git add. Our CI pipeline ran successfully, but it indicated another repo. I have it in my repositories list. It is Flask hello. So it actually changed that file, not the one I have. See, I have a Flask hello here, but we are working with hello world, and it was 4 minutes ago changed. So we by mistake changed the other one. So no worries. Now we have changed the name. Git commit. Let's type in 2 here for the second one. Okay. Press enter and again git push, and now we should see. Okay, I think there's an pull error. Okay, I have to forcefully pull. Okay, let's see margin error because I didn't pull the previous one. That's why it is giving me an error. No worries. Here you go. Now it should work. Git push. Yes, it worked. So again, let's go to our actions. We should see a new pipeline running. Here you go. Let's go inside, build an update, and it is building. Let's wait for a bit, and we should see a green tick mark here, and we are done. We are done. We should see a new Docker image in our hello world repo. Let's refresh that. And here we go, 2 minutes ago, and we have 816 at the end. The deployment YAML should also have 816 at the end. So let's go and let's check whether we have successfully changed it or not. 816. Here you go, guys. Our CI pipeline is ready. It is basically doing whenever we change the app.py or the main branch, it is creating a new image and pushing it to the DockerHub, and it also changing the current image in that YAML file in deployment. And whenever we change deployment YAML, it will trigger ArgoCD. But we haven't done the ArgoCD part. Let's go for the second step, that is ArgoCD installation. So how to install ArgoCD? Just type in ArgoCD CD in Kubernetes. Kubernetes. It will redirect you to the official documentation. Go inside and we should see the steps. Here you go. Copy this, copy it. Then let's get back to our machine. Let's paste this, press enter, and we should see ArgoCD is being created. It will take a bit of time, but not much. The namespace got created and ArgoCD is installing. Fine. We have installed ArgoCD. If you want to see what is inside, let me show you. Get all in the new namespace called ArgoCD. And here you go. There are these services already created by ArgoCD, and the rest of the stuffs as you can see here too. The pods are currently still creating, so we have to wait a bit. So I think it should be created by now. So let's again enter the same command, and all of the pods are running. So we are good to go to work with ArgoCD. Clear? Okay, fine. So how to see the ArgoCD UI? Well, we can expose a port called ArgoCD server that contains the UI of ArgoCD. Okay, and it is in port 80. Clear? So let's open this in a new terminal. So to see the UI, first we need to change the service type of ArgoCD. If you again see that the ArgoCD server is cluster IP. Cluster IP won't allow us to uh, to for, to see the UI. Okay, we can do port forwarding, but my experience is that port forward doesn't always work. Okay, so and plus in production we don't use port forwarding, rather we use load balancers. So let's do load balancer instead. To initiate a load balancer type instead of cluster IP, we can use this command. You can do it kubectl edit, but I have a command here. Just we're going to use kubectl patch to avoid the hassles, and press enter. And now if you again see the services, get svc in ArgoCD namespace, you should see that it is now changed to load balancer. Okay, so, sorry, I haven't changed it. It should be load balancer, LOD balancer. Clear? Okay, now it is patched. Again, let's see the servers. Here you go. And where is the server? ArgoCD server, and it is typed load balancer. This means behind the scene, a load balancer is being added to our ArgoCD server endpoint, and we have an external IP2 to reach it from outside. So let's click on this. Okay, let me copy paste and then go to the URL manually, and it will take a bit of time because behind the scene the load balancer first it has to be created. Okay, so it will take a bit of time. After it has been created, we would be able to go inside. And okay, let me again refresh this. By that time it will give us errors, so stay with me. So after a few minutes, I think almost 2 minutes, we are now here. So your connection is in private. This is because we are not following the best practices. We haven't attached any certificates or TLS or whatever for the security. That's why it is giving us this. But it is okay for demo purpose, and so we can advance. So type in advanced and continue with this link, and we should see our ArgoCD UI has loaded. So for this, we have to give the username. The first one should be admin. You can change it later and set it up. And the password. How do we get the password? So to get the password, first let me show you the secrets in ArgoCD namespace. ArgoCD. And here you will see something called ArgoCD initial admin secret. This is the password. Okay. So let me see that secret in YAML. Here you go, and this is the password, but it is encoded into base 64. So to get the actual password, we have to decode it, and this is how you decode base 64 and press enter. This is the initial password. So copy and paste it here and sign in. So what's the reason? I think any misspelling or what? Let's go. Admin, it's fine. Okay, let me again. I think very careful about including any spaces. So let me do that again. Echo, fine. Let me remove the colons. Then let's do. Oh, that's the problem. I forgot to decode. -D. Okay, guys. So this is the actual password. My bad. Sorry. Let's copy this one. This time it has to work. Don't worry. And sign in. And we are inside ArgoCD UI. Okay. After that, to create an application, click on create application. Then application name, give demo, uh, and project name default. Manual sync policy is automatic. You can do if you like 3 of them. Let's skip the last one, or let's give it. Doesn't matter. If you know the details about this, you can do a bit of research, but I'm not diving into this. All of these 3 has some special characteristics or advantages. Okay. Next, sync options. If you know about them, you can add them. Repo link. So we have to go to our repo. Let's get the URL for it. Code, and here you go. Here you can see the URL. Copy this and paste it here. We are done. For head, it won't be head. It is main. The main branch is main. Okay. It is not head. Clear? As you can see here, main. So we have typed main. Then the path would be just dot. Okay, so whenever it goes inside the project, in the dot part there would be everything. So the destination would be whatever it says, and namespace is default. Be very mindful about this. Don't skip this one because all of our files are in default namespace in EKS. Okay, in EKS cluster, all of our files are in default namespace. Let me show you. kubectl get all, everything is here. Hello world and everything. And one of the many major thing to remember is that don't forget to add your namespace in the YAML file in the deployment. Okay, yes, if you don't include it, it will create in the default namespace, but ArgoCD needs it. Okay, if you don't mention it in the YAML file, ArgoCD will give you an error. I faced it. So yeah, both for service and for uh, deployment. And next, further down the line, if you create anything, don't forget this namespace. Okay, I got an error, so this was the solution for it. So after that, you can keep everything as it is. You can also edit as YAML if you want. And here you go, the YAML file. Okay, I have created an YAML file for you guys. I'll be adding it in the repo. If you want, you can, if you want the same configuration as mine, you can copy and paste it here. Okay, it is exactly as it is, nothing changed. Okay, and from here we can save it as well. Okay, and you'll see every configuration set according to the file that I have just added. After that, just click on create and you'll see that ArgoCD will create an application. Click on this and it is loading out of sync and done. ArgoCD has been synced with our GitHub repo, and you can see that it has created in our EKS cluster. There's Flask Hello service, there's Flask Hello uh, deployment, and there's the service monitor all in action. Okay, and app is healthy. If it is not synced with the GitHub repo, it will you will see that and sign. Okay, and you also can see the difference. Since I'm already synced, I can see it. So anything out of sync, you'll be able to see it. Now the main purpose of CD is that if we change anything in our deployment, right, anything in the deployment, it should automatically be in the production. So let us do that. So we are changing the replicas from 3 to 5 and saving it, and let's deploy it. Okay, let's push it. We are not deploying, guys. We are not deploying. We are not going to use any GitHub kubectl code. We are just pushing it to the GitHub repo. Okay, commit. Let's add the message replica from 3 to 5. Clear? And press enter. After that, git push. We haven't manually typed any kubectl command to change the replica set from 3 to 5. We are just going to change the deployment in our GitHub repo and push it. Okay, let's push it. Okay, what's the error here? Merge issue again, merge issue. So I think I have to pull first. Okay, never mind. Okay, now it should push. Here you go. So it has been pushed. If you see here, after refreshing, we should see replica is 5 in our repo. Replica is 5 and I haven't touched the kubectl or EKS. So let's go to our ArgoCD, and by default ArgoCD refreshes every 3 minutes if I'm not wrong, but we can do it manually. So let's sync it. Synchronize. Okay, and here you go. As you can see from the chart itself, there are 5 pods created. 5 pods. As you can see, if I can zoom out a bit, 5 pods created. I haven't touched the EKS, right? So let me show you now the current uh, cluster get all. In the default space, we are running 5 replicas. So just changing the code in our GitHub repo, it is actually changed the production environment. Okay, let me again show you guys. Let's convert this from replica 5 to 2. Okay, let me again run it. Control C, then git add, git commit /m from 5 to 3, 5 to 2, sorry. Git commit and git push, and it is pushed. And if I go to the ArgoCD server again and click on sync, synchronize, we should see it has decreased the number to 2. See, it is decreasing. Let's refresh, and here you go, we have decreased from 5 pods to 2 pods. Okay, here let us stop this, sorry, let us stop this, and again see what we have. Get pods, we should see we have only 2 running. Here you go. So this was the CD part, guys. We have successfully done our part 4, which is the last part, ArgoCD. So at last we are finished with our end-to-end DevOps project level 0, that is connecting the dots. We have created a Flask app using Python Flask app. We have used GitHub for version control. We have used Docker for containerization. We have used GitHub Actions for CI. After that, we went for our part 2, that is creating a cloud infrastructure for deployment. We have created Kubernetes in AWS, that is EKS, using an IaaS tool called IAC tool, that is infrastructure as code, Terraform. After we have created the infrastructure, we went for our part 3. We deployed our deployment YAML manifestation file, and we observed using this observability tool called Prometheus and Grafana. After that, we went for our part 4 and the last one, that is CD, ArgoCD, for continuous delivery. And the main goal of our entire end-to-end project was to give you a minimalistic, the most bare minimum code for each of the steps, okay, so that you have a base or foundation to build upon later on. Now for the testing purpose, that whether we have successfully created or not. So let us go to our machine again. We are going to only change this code in our GitHub and push it. We want to see whether the container has been created and pushed to DockerHub. We want to see whether CI has been running perfectly. After that, we will see that whether Prometheus and Grafana is working fine or not. Okay, and finally would again make a second commit to see whether that commit has been picked up by ArgoCD or not. So let's go. Let me first show you the current scenario. Here you can see that this is our code space. We have already port forwarded our running code in our EKS. Okay, we have Grafana running perfectly, we have Prometheus running perfectly. Okay, so let's do a manual push in our GitHub repo. Let's edit this. So I'm using console. Let me add final check. Okay, and let me commit the change. This would trigger our CI pipeline that we created. Our CI pipeline does 2 things. Okay, let me first show you, tell you that our CI pipeline does 2 things. First one is it creates and pushes a Docker image to DockerHub. First it creates the Docker image, then pushes it. The second one thing that it does is that it changes the image parameter in our deployment YAML. Okay, so first let me show you that so that you can compare. So let me cancel this. In our deployment YAML, yeah, discard the changes. We currently have 816 tagged at the last, okay, image. So you will see that it has changed, and if you go to the Docker Hub, currently we have 816 about 1 hour ago. So now let's do the editing. So what we did a bit earlier. So let's write again, final check, and commit this. There would be an automatic commit message. It's still thinking, come on, yeah. And when we push these commit changes, the CI pipeline should run. So we committed and pushed. Let's go to the actions. We should see a new CI running. Here you go. You can click on it, go inside again, and you should see all of the steps running. Our build and push step is running. It has logged into DockerHub. It has generated a tag. It has built and pushed to our DockerHub, and now it is changing the deployment YAML. And here you go. We got the green tick mark, so we can check that. Let's go to the deployment file, see whether the changes has been made or not. Here you go. 527, the new image tag. So that means a new image with a tag at the very last 5 to 7 has been created and pushed to our DockerHub. So let's go to our DockerHub and refresh. Here you go. 5 to 7, right? 5 to 7. And here you go. 5 to 7 created 2 minutes ago. Now that means our Flask hello world is fine, GitHub version control fine, containerization fine, and we pushed it. CI is also fine. And we mentioned that CI has two things. It's for the second thing, it changes the deployment YAML. And we know that whenever we change deployment.yaml, ArgoCD gets triggered. So let's see whether ArgoCD uh, got triggered or not with the new YAML file. So the new image. So let's see. Here you go. And we can sync it manually. It should trigger every 3 minutes, but we are not waiting for the 3 minutes. Okay, so let's do manual sync. Here you go, out of sync and sync. Why? Because it has now generated the hello world pod with a new image. So if we go inside that, uh, let's see whether we can find the new deployment.yaml here. Where's the image? Okay, let me type image. Where is it? Yeah, 5 to 7 has been added. 5 to 7 has been added. So our ArgoCD also works. Our ArgoCD also works just fine. It responded to the change made in the actual code. And for observability, I have already shown you that Prometheus is running. Here you go. Hello world is, and everything is green. And we can see a beautiful dashboard here as well with Grafana all working. You can explore this chart if you like. We can go to our Flask hello SM, hello world SM. Okay, click on this. You can see the hello world too. Compare. Yeah. So that was it. So guys, everything is running fine. CD, observability, EKS, ISE, CI, containerization, version control, and our Flask app. So mission successful. So yeah, is it done? No. After we are done with our coding and experiment, we need to delete or cancel the infrastructure. Okay, else there will be bill. So how to delete? Since we have used a load balancer, remember, we have used a load balancer for ArgoCD. So we need to cancel that ArgoCD load balancer, right? Or change it to, either we can delete it or change it to cluster IP. Okay, so we are going to change it to cluster IP. We have the code line here. So let's go and change our, yeah, so it is repatched. So if you want to see again, keep CTL, let me show you. Okay, I can show you from here. ArgoCD server. Okay, never mind, get SVC. Get SVC. Here you go. And it is cluster IP, meaning behind the scene the load balancer is getting deleted. Okay, that means if I refresh this, it will give me error because the load balancer is off. I can't access the ArgoCD server UI from the internet. Clear? So we have deleted the load balancer successfully. Now to destroy the entire infrastructure, simple command Terraform destroy. It will take 15 minutes almost, or 20 minutes. Let's enter. It will ask for a confirmation. We need to type in the confirmation yes, and when we click enter, the deletion starts. So guys, let it delete, and after 15 minutes you'll see the deletion is successful. So let's not wait until then. So yeah, this was our entire end-to-end DevOps beginner friendly project level 0, connecting the dots. Thank you.